Ladies and gentlemen, welcome to the first Digital Industry Summit of MAN Energy Solutions and H-TEC Systems. My name is Robin von Plettenberg and I'm the CEO of H-TEC Systems. And today I want to give you a brief presentation on H-TEC and how we are driving the scale-up of green hydrogen. Besides being the CEO of H-TEC, I also have 4 children, so you can say I'm a busy man. And when I think about the climate change, I also think about my children. Because by the time when I will retire, and maybe my children will have families, by that time, we have to have the climate crisis solved. And green hydrogen is going to play a crucial role in that. When I look at different applications that we need to bring down to 0 carbon emissions, there's one part which you can electrify with renewable energy. Residential heating, urban vehicles, and so on and so forth. But there are certain applications where this is not possible. And there it is necessary to have green hydrogen as a solution in order to decarbonize these applications and in order to bring the world to a net zero world. So if you look at chemicals and refineries, if you look at steel, international shipping, long-haul aviation, seasonal storage, these are applications where hydrogen is necessary in order to decarbonize them. And there is a number of applications where there is a lot of discussions whether it should be rather electrified or whether hydrogen will play a role. I think there is a role of hydrogen. I think it will be a matter of a business case in each application and also in each geography. So in some areas, there will be electrically driven trucks. In others, it will be hydrogen trucks, and so on. I see our task as H-TEC to be as attractive as possible for green hydrogen, because if there's a good alternative, this will also help to decarbonize the world. Our vision at H-TEC is to avoid 1% of all the global CO2 emissions. That's a huge task. It's a very tall order. And given that we are only a small company today, it's something that is really difficult for us to wrap our head around. But it is possible. And it electrifies and motivates our people, and it helps us to drive towards this specific goal. And the reason why we can formulate and put ourselves such a huge target is that we are in a very strong position with regards to our setup. Firstly, we are around for 25 years in PEM electrolysis. So we have a very good and strong technological understanding of PEM electrolysis. We are a 100% daughter of MAN Energy Solutions, but we have a very independent setup. So we are not part of the corporate processes and structures. And this helps us to be very quick and nimble in our decision making. So we can move very fast. For example, we brought our number of employees from 100 at the beginning of the year to 280 today. And we have sufficient financing. Our mothers have committed 500 million euros, which is a very large number for such a small company as H-TEC. So you can say as H-TEC Systems, we have a very strong core. But not only that. Since we are being part of the MAN group, we can also build on the strengths of MAN. I'm a former MAN employee. Also one of my board colleagues is. And throughout our organization, we have some people from MAN. And we get very strong support whenever there is something that we as a small company cannot do as well. MAN, of course, has a very strong industrial experience over not only decades, but centuries. And there's a huge competence when it comes to executing large projects. There's an EPC plant competence. There are industrial compressors and reactors, so other parts of the value chain. And there is a global sales and after-sales network of more than 120 hubs around the world. And these resources and competences are really easy for us to access and which can help us to serve industrial customers. And there's a third element, and that is MAN again is a 100% daughter of Volkswagen. And when we're talking about the scale up of the electrolyzer industry, we are talking about industrializing supply chains. And there's no industry that is as good as building up these industrial supply chains, serious production of complex products than the automotive industry. Volkswagen is the biggest automotive OEM, and there's a huge competence that we are building on when we're building new factories, when we are building up our supplier network, developing, validating suppliers, and so on and so forth. And last but not least, with being part of such a big group, we also have the financial security, the bankability. So our customers can rely on us being around for a long time. What we are doing as H-TEC Systems is we take renewable energy, be it solar, be it wind, be it hydropower, and we use that to split water into hydrogen and oxygen. And this hydrogen, as I've shown before, can be used in a multitude of different applications. And we at H-TEC, we are also serving all these applications. So there is a market for smaller electrolyzers in a containerized outdoor way. And there is a market for larger ones, which will be plants in buildings. And we will address both. We have a 25 years of experience, and H-TEC System was founded 1997, and it was primarily focused on research and education in the beginning. In 2010 and 11, GP Joule, a very innovative and pioneering renewables project developer, took over H-TEC Systems and brought the company more and more to bigger plants. So there was an electrolyzer launched in 2017. Our core product today, it was launched in 2019, which was already bigger. Then in 2021, MAN Energy Solutions took over completely. And now in this year, we have reorientated ourselves towards a much more ambitious goal, as I described earlier. Our North Star is to abate 1% of global CO2 emissions. And this is the path that we are now pursuing. Coming to our product portfolio, we are building on a stack. The stack is the core component of the electrolyzer. And our stack, the S450, we have developed in the year 2017. And since then, we have gathered loads of experience, 5 years, more than 70,000 hours in the field. And we have optimized the stack, and it's highly reliable and very efficient and has a very good performance. And we're using this stack in different electrolyzer plants. Today we have the 1 megawatt ME450, which is a turnkey solution, 1 megawatt optimized for plant sizes of 1 to 2 megawatts, sometimes 3 and 4 megawatts. The next bigger solution is our hydrogen cube system, or short HCS, containerized. These are 2 megawatt cubes containerized, which can be combined to 4, 6, 8, 10, also 12 or 14 megawatts. And next year, we will launch our first indoor solution for very large plants that will be in a building. And they are built on 10 megawatt modules, which can be combined to 100 megawatts. So you can see we are growing the plant sizes that we are offering, and 2023 will not be the end of the story. There will be bigger plants and bigger solutions coming as well. Having said that, we are not focusing only on the big plants. We will continue to serve the segment, the containerized segment of 1 megawatt, 2 megawatt, and so on. So what makes our electrolyzer special? Our target is to produce green hydrogen at the lowest possible cost, the so-called levelized cost of hydrogen, which are considering all the different factors of the process chain. And when you look at the LCOH today, they are primarily driven by the electricity cost. So about 70 to 80% are out of the LCOH are electricity cost. So efficiency is very important. And we are very happy to say that we have the best efficiency of PEM electrolyzers in the world, 74% for the whole plant at 30 bar level. This is a very important factor. Secondly, it's reliability. I showed you that the stack that we are building on has a lot of running hours, and we have a lot of experience with it. And we have a concept of inherent redundancy with rather small stacks that can easily be exchanged if there is a problem. So reliability is the second. The third one is the fast ramp up and load changes as you have it with PEM electrolysis. This is important because if you're working with renewables, they are fluctuating, and the better the electrolyzers can ramp up and down, the better it is because you're not losing electricity. And as I said, electricity is the main driver of the cost. We are also building on unique supply chain capabilities. We are building a gigafactory in next year, and we're building on the support of our Volkswagen colleagues, as I explained earlier. PEM electrolysis does not use any toxic chemicals, so there is no risk of environmental hazard. In fact, our electrolyzers are even standing in a Swiss natural reserve. And finally, we are a trustful partner. We have the bankability, and we have the proven project execution capabilities of MAN. Also, our service is quite unique. We are basically offering 3 packages. Starting at the bottom, there is constant remote monitoring from our control center in Augsburg, so that we are able to recognize problems in the electrolyzer, not only when they occur, but even before they occur. We are analyzing a lot of data, and we are developing this product more and more so that we really get more and more into this predictive monitoring mode so that we can inform the customer before something happens and then take preventive actions. Then secondly, we have a package of revision and repair where we are doing regular health checks on site and repair components so that the plant availability is very high. And then finally, we can even go to operations and maintenance, basically a full service package and run the electrolyzers in an optimal way so that you get the lowest levelized cost of hydrogen. Coming to our production sites. Today, H-TEC has 2 sites. There's on the one side the Hamburg location, where we have our competence center for the stack. So there's all the R&D for the stack, and there's the stack production. And we are planning to open a gigafactory by the end of next year. In Augsburg, there is the competence center for the electrolyzer as a whole. So all the balance of plant is being developed and produced in Augsburg, and we have our technical service center in Augsburg. Now coming to our capacities, we have an ambitious plan to extend our capacities with our gigafactory that we can step by step increase. It will be online in 2023. We will use 2024 to ramp it up. In 2025, we can already deliver more than a gigawatt, and we can extend that to 6 gigawatts by the end of the decade. And that is only one shift. So there's even more potential to ramp up and serve a large supply base with our own production. We are also not only building on Volkswagen competence, but we are in a research project, H-TEC, for industrializing the PEM electrolyzer production. And we are building on a supplier network, which is global. So we are increasing the plant sizes, we are increasing our capacities, we are building our personnel, and we are also increasing our regional footprint. And today we are focused on Europe, but we will step by step also address other world regions and then service the whole world. And we can build on MAN's PrimeServe service network with more than 120 hubs. So literally all the big electrolyzer projects in the world, we will have a hub close by where we can service, where we can make repairs and serve our customers locally. Maybe some of our reference projects that we have done so far. There is one quite famous e-farming project in the northern part of Germany. Quite famous because it is really a pioneering project. It's about mobility, so refueling stations, and also a district heating where the heat of the electrolyzer is used for nearshore residential heating system. We have an application in Haurup where we are feeding directly into the gas grid, and the electrolyzer is steered in a way that whenever the electricity prices are low, it starts producing, and when they go up, it goes down again. We have one in Sweden with a small microbit grid solutions. We have one in Switzerland, which is hydropower, located in the natural reserve, as I mentioned earlier. We have one interesting project in Germany, a 2 megawatt project, which is an open skid. So basically our containerized solution without the walls of the container. And it's feeding for a local, the hydrogen into a local steelworks. And finally, we have also sold our first HCS system for a mobility application in Switzerland. Just 1 month after we launched it to the market, we already sold it. It shows that the customers are really keen on getting our products, and there is a huge interest. Now let me close with describing a little bit the ecosystem that we are in within MAN. So the MAN application portfolio along the hydrogen value chain is quite broad. Besides H-TEC systems and the electrolyzers, there's also competence expertise for cryogenic storage systems. So big cryogenic tanks that can be used for hydrogen. There is a very large market share of engines which will be fueled in the future by hydrogen-based e-fuels. We have reactor technology and competence in our Deggendorf plant. We have turbo and screw compressors which can be used to compress hydrogen. And finally, there is EPC competence that can be offered as well, and that can be used to combine all these different parts of the value chain. It's a whole ecosystem that allows us to offer full solutions to our customers. With this, I want to close and thank you very much for attending this call, for listening in, and I hope you have a very interesting and inspiring day at this first Digital Industries Summit.
Welcome everyone to our today's session about references for CO2 compression from MAN Energy Solutions. It's a pleasure having you today here. And first of all, I would like to welcome our senior expert, René Dittmer from MAN Energy Solutions Berlin. And he will guide us through our references today. So thanks a lot, René, for being here today and explaining a lot about references.
Yeah. So my name, he mentioned, is René Dittmer. I'm part of the sales team in Berlin. We take care of designing the machines, quoting, and also taking the new developments. Let me start with a few special references because there are more. This is one of the ancient references. 30 years ago we sold one of this unit. Now today we have 3 units in the field. Special about this is it's old. I just had the pleasure to redesign it these days, and still today it's a challenge to design that machine. It's an air-cooled machine, which is even more challenging. So, and it's an extreme extremely pressurized machine going up to 200 bars. It's one of our best references in the field.
René, explain us a little bit about the nomenclature for the type. So RG stands for integrally geared type compressor, right?
Correct. Integrally geared machines, it's the German one, but the G is helping. It's a gear type machine. AT means the first impeller diameter in centimeters, so it's 800 millimeters, nearly 1 meter diameter of the first impeller, and it's 8 stages, which is required to compress the gas from atmospheric to 200 bars. Yeah.
And René, these machines are typically speed driven, or do you have inlet guide vanes, to adjust the flow?
Correct. Those machines are fixed speed machines typically, because you have 8 stages, meaning you have 4 pinions running on this machine, so 4 times critical speeds, meaning that you barely find a window for rotor dynamics to allow for variable frequencies. Yeah. So the IGBs are perfect for flow control. So we do not need a VFD in this case. The suction conditions are pretty constant. Discharge conditions are varying sometimes pretty much, and we can cope with that. And these machines are extremely both economic, efficient, and robust.
And maybe a last question to this reference. So if you have a look at the type, is it rather a small machine or rather a big machine in our portfolio for CO2 compression?
At the time we sold it, it was one of the biggest in the world. It still is rather large machine, but speaking of today, it's a mid-size machine today. Right. Let me go to the next one. That is round about the same age, but it's extremely special because it's a 10-stage machine, so you have, which is extremely special, and there's not a second in the world. It's having 5 stages or 5 pinions running on the bull gear. You see it's barely not enough space to fit all that. Beyond that, it's rather small. That's why you need 10 stages, and speeds we are facing are extremely high. So even today, we would try to avoid this 10-stage design, going further to an 8-stage design.
And I think this design has 2 bull gears, is that correct? That is really a special one, right?
It is more than special in terms of bull gear. Yeah, correct. This machine is situated in Canada. It's a more recent machine. It's sold in 2009. In operation since, let's say, 2012. SAS Power is a coal-fired power, is operating a coal-fired power plant, and they are sequestering the CO2, and they have the option to serve EOR, which is a business case in Canada, US. Right.
Okay. And I see you're talking about wet CO2, so that is possibly then something special for materials, or what does it mean?
We see wet CO2 is asking for special attention. So you face condensation in the coolers, you need stainless materials, you need temperature control and all that. That's kind of adding to the challenges of CO2, which there are anyhow. Yeah, correct. And it's not special to the machine itself, it's furthermore special to the system design. Cooler design need to be taken care of. You need to knock out water and you need to handle it properly, right? And what you knock out is still sour. So, yeah, it's special.
And René, you're talking about coolers, so it's not only the machine, but also we are, designing the coolers and everything around. Is that correct?
Yes. So we take care of the whole kind of machine from suction to discharge. Especially today, we are also taking care of suction side of the customer, so like process side and discharge pipeline side. You see it's still operating at 170 bars. Supercritical CO2 is asking for attention in terms of temperatures and pipeline filling, start, up, stop. And so we simulate the whole thing. And sometimes dynamic simulations are required, and we can do that.
Sounds that we are really a solution provider, like in our name, MAN Energy Solutions, correct?
Yes, it was from beginning, but especially today that comes up even more. It's getting more and more important to see the whole picture and to optimize. Even today, we are optimizing with the customer, not only for our own product. This one it's also a public project. That's why the customer is very open. They have lots of public funding. That's why we get in all the information. We have a confirmation of a very high availability, 98.7% of that machine. It is our largest machines in terms of mechanical dimensions. It's not the largest in terms of density, power density, but suction pressure is pretty low. And at that time, it was the largest unit. RG90 is you're nearly having 1 meter at first stage diameter. And on top of that, this machine is having water coolers and air coolers, which is posing issues as air coolers are large, so reverse rotation is an issue. Still, it's very optimized in terms of efficiency. And the discharge range is extremely wide, so we never had that before. And we found a solution to cope with the customer requirements, and it is functional, right?
And I see you're talking about customer, I see Shell, so that is the end user operating this machine?
Yes.
And obviously, since we have an availability of 98.7, I assume that the customer is pretty happy, is that correct?
Yes, they proved themselves correct. They ordered the second machine this year.
Wow.
So I'm pretty, we are pretty proud to have this second machine. It's a smaller unit, but the reason for this order is definitely this project here. Yeah.
And I think you are also the man who sold the second machine. And
I was just the one who put in place to quote, and yes, we got the
excellent.
Order. Correct.
Fantastic.
Right. Another special project. This is a machine in Saudi Arabia. We sold it in 2011. It's in operation since 2015-ish. Still a high pressure unit, but in the desert. And so it's a special thing talking about cooling, and the customer installed a cooling tower. That's why we have pretty normal cooling temperatures. It's a mid-sized unit, and we tested it in Oberhausen completely. We set up the whole structure. We learned a lot but still this machine is very, very successfully operated in Saudi Arabia for years. And we receive new inquiries from this region just because of this successful reference. Yeah.
René, one question, you're talking about testing. So do we need to test all of these machines, or do we have enough experience and enough references to explain to our customers that we don't need a test, a thermodynamic test, for example?
From today's point of view, we are, for rather standard machines, we can skip the performance test because it's extremely expensive. You need to set up a lot of coolers. All that we see is something not fully necessary because there's always a site performance test. What we do is we do a gear test, which we see kind of necessary to prove our mechanical design, our manufacturing, all that, to prove that correct. And that's always taking place.
But that sounds like a benefit for the customer. If you can skip a thermodynamic test, means delivery times are going down?
Yes.
Okay.
We are saving months. Correct.
Excellent.
Yeah. Yeah. This one is just another wet gas CO2 compressor. The special thing about that, it's a low pressure unit. Yeah, but every unit we saw before was also having this low pressure section. But here we're talking about methanol production. So Saudi Arabia is using CO2 to produce more methanol instead of polluting the atmosphere. And that is something we see more and more. We have another machine in the US. So those machines are high spec. They are wet CO2, so you have all the requirements. Only the specific discharge requirements are a little relaxed. Yeah. But it's a clear utilization. So that's the next level of CCS, so to say, CCUS.
So we're also building smaller machines, not only the big ones.
Yes. Okay. We always think that we are not competitive in the smaller units, which is to some extent true. But we can do it, and we can also build extremely good machines on this level. Sometimes the customer is not willing, the project is not willing to pay the money. Correct.
Just one question, because we're talking about the integral gear type machines. That looks like a very compact machine in terms of, if you compare these to inline machines, to barrel type compressors.
Yeah.
So can you maybe explain a little bit why we're using these machines?
That is the history of the last 30 years. So this question came up 100 times. So yes, it is much more compact for CO2. The compression ratio in a single impeller is very high. So you can go up to 3 in one single impeller, which is not the case on like methanol or hydrogen. And that's why on CO2, you have kind of this urge to use different diameters, different speeds, to use as much as you can. You use intercoolers, because high compression ratio always means heat coming into the gas, and so you need to take out the heat from the gas. You can improve performance and all that. So all details on CO2 come up with an integrally geared solution. Yeah.
Sounds like a perfect solution for our customers.
Yeah.
Thanks.
Yeah, this one is an order from last year. It took about 5 years to develop that, because that's a real solution. We did not have, at the beginning, we did not have the capability to calculate all that. It's a machine which was designed and pre-engineered with HYSYS. The customer came up with the idea, it's Aker solution. They are trying to decarbonize a cement plant. They are recently setting up the site So all the site activities are starting. Especially about the machine is we are generating heat. We are kind of integrating the heat. We are using the heat in terms of speed, terms of steam, to produce or to capture CO2. So 50% of the capture requirements in terms of steam is coming from the compressor, which is huge. It's a lot of 2 digits, 1,000 kilowatts in terms of speed heat. Why is it so big? That's coming up. So that's the suction line. And the special thing, this suction line is carrying not just wet CO2, but the portion of water is like 50%, which is never been in the past. It says there's no compressor having this much of water, and there is still no scientific proof of the gas properties of this mixture. So we designed something which is pretty special. So each stage has an intercooler, that's normal, but here we replace them by steam generators. So we take, the whole machine is pretty hot, like near to 100 degrees. We are just boosting the temperature always like to 200 degrees. And in the steam generators, we generate low pressure steam. And that is directly going to the dissolver, not asking for a steam generator fired by gas or oil. Yeah, that's the deal.
But René, it looks very complicated to see where the compressor is. I mean, it's a huge system.
Yeah.
So I think the compressor is over here.
Yeah. It's just the heart of it all. It's a 4-stage machine, 4-stage groups machine with 7 impellers.
Yeah.
And yes, it's kind of the unit with the highest number of valves in all that. So you don't see it here, but it's kind of an unlimited number of valves to make it possible to control the whole thing. Yeah.
Impressive.
Yeah. Correct. It's kind of just a last thing on top of that. It's a CO2 compressor and a heat pump with a very high COP, which is not to be compared or mixed up with the normal heat pump you have for houses. We are much higher than that.
And COP means coefficient of performance?
Performance for a heat pump.
And it's an indicator how efficient.
Yes, how much energy do you need to produce an amount of heat.
Okay.
Yeah, right.
Understand.
The last thing, that's kind of an upcoming project. We are already engineering the compressors here in Portus. The Netherlands are setting up a CO2 pipeline where they are collecting low pressure CO2 to be pumped offshore. And our compressors are here just at the shoreline, in that building, just in parallel, because the mass flow we are compressing is like extremely high, not to be compared with the other references, because we are just compressing from a number of producers, and we are producing to not only one discharge pipeline, but we are producing to 2 discharge pipelines with different pressures and different temperature requirements. That is resulting in a pretty challenging compressor setup and design, correct?
And René, all these blue marks, these are the emitters, and they are collecting the CO2 into this pipeline. Okay,
correct. Understand. And we are currently working on the low pressure compressors as well. There are a number of customers, but there are more to come. And also those will be large compressors and small. That's kind of whatever plant they have.
And I think customers you're talking about are ExxonMobil, Shell, Air Liquide, and Air Products.
That's correct. So I think Air Liquide is what we see we have a good relation with, And so we know most of their activities. Shell we are approaching, and we are discussing how to optimize their processes. ExxonMobil and their products we are approaching, but they are to come. That's something for near future. Right.
Good. And good luck with this nice reference.
I think it was the last slide, so I guess we are at the end of the whole thing. Yeah.
Excellent. So René, thank you very much.
Yeah.
And that means, in case you have any further questions, you can just contact us, and we are very happy to explain more in detail about our running references for MAN energy solutions for CO2 compression. Thank you very much, René.
Yeah.
Thank you very much for listening.
Thank you. Bye.
Welcome to wherever you are in the world at whatever time you're listening to this digital conference. I'm Christian Rufer. I'm head of business intelligence and business development, and I will take you through what we call the carbon ABC. It sounds quite simple, but actually there's quite a lot to it, and I want to go through this with you now. So here we go. The title page, the carbon ABC, all you need to know. And finally, our agenda for this webinar. First of all, the challenge. Why are we doing this? And in the second step, the A of this challenge. Well, avoid CO2 emissions. And then followed by balance. We balance out production of renewables and consumption of renewables that also avoids carbon dioxide emissions. And finally, there will always be something that you will have to capture because we produce so much carbon dioxide. And finally, a roundup. So the challenge is basically that our remaining carbon budget is about 500 gigatons in total. After that, we will have exceeded the 1.5 degrees temperature rise that was set by the Paris Agreement. And that is about 15 years of our current carbon production. If you look to the graphic on your right, we have this 1.5 degrees Celsius here. This is the limit. And here, a graphic depicting the change of temperature as the total carbon emissions have increased over the years. So today we're around 2022, and we still have, for this average expected 1.5 degrees temperature rise, still about 500 gigatons of carbon dioxide to go. And thereafter, it's very likely that global warming will be above 1.5 degrees Celsius. So why do we do this? CO2 contributes to global warming, and with increasingly human activity, there will be more CO2 in the atmosphere if we don't do anything about it. CO2 has an ability to absorb radiation and therefore increases the global temperature. And in our lives, in our busy lives, we don't really notice this. But there are sensitive environments that do notice this. These are the polar caps, the glacier, the deserts, and so forth, where the change is very noticeable. So there's definitely an urgency to act so that we can preserve our habitat. So our obligation is quite simple. The Paris Agreement also puts it down in a very, very simple paragraph. And verbally, holding the increase in the global temperature to well below 2 degrees Celsius above pre-industrial levels, and pursuing efforts to limit the temperature and to increase to 1.5 degrees Celsius. On the other side, the Intergovernmental Panel for Climate Control has different pathways of how we can reduce our carbon dioxide emissions. And most of them indicate that we should reduce our carbon dioxide emissions by 45% from the 2010 levels by 2030. What you can see today is that the status is that we have not been very successful in this enterprise in the last years, and that in fact, against a linear reduction, there's a 10.5 gigatons per year of emissions gap so that we can reach this intermediate target on our way to zero. The task is a very interesting task. We have to build a new energy infrastructure. This is a huge opportunity, and we don't have very much time to close this gap. We say this would be 10 years. Just think about it. the horse buggy was replaced by automobiles in about the same period of time. We believe that we can do this today as well. The technologies are available. Many technologies are already in operation. The thing is that we must channel our resources so that we can revolutionize this energy supply infrastructure and material supply infrastructure so that we can move forward. And this is not a single person company government that will be able to do this. This is a challenge where we all depend on each other. We must all act and we must all collaborate so that we can get where we want to be and preserve our future environment. The infrastructure, well, this is a very simple schematic of this infrastructure. It can't be built overnight, but just think about it that we will start out by capturing the emissions of carbon dioxide from existing plants. We can't get rid of our existing infrastructure right away. And basically, we can pipe the CO2 where, especially in the beginning, a lot will have to go into geological storage. Certain models say between 5 to 10 gigatons per year will still have to be geologically stored in 2050. So this infrastructure is not something that will disappear rapidly, but in time, as renewables increase and hydrogen production increases, we will be increasingly able to produce the chemicals that we use daily for plastics, for fuels, by synthesizing with hydrogen with CO2 to produce these fuels. But also, naturally, hydrogen will also be in this, let's say, pipeline infrastructure of the future, a very large part of this energy in form of direct combustion or in fuel cells or in the production of green ammonia. So this is how we then came to our ABC. We say we want to make this, or to understand this better, we want to classify our technologies in technology that avoid emissions. This is basically efficiency. If something is efficient, we avoid. Substitution, if we replace a technology with the other technology, then we also avoid CO2. And finally, we can use the CO2. This avoids emissions. Then there's a very big problem of being able to balance demand and production, since renewables are not produced at the same rate as we demand these at the consumer level. So we will need storage, we will need conversion of electric energy to other forms, and we will need some, what we would call also an electrical grid reserve capacity, so that we can provide users with electric power when they need it. And finally, capture. There will be no way around capture because we simply produce so much CO2 today that we will have to capture it. Some of it can be reused and some of it will have to be sequestered. So let's go to avoid. Avoidance is not about this austerity, as many people sort of think at the first approach. It's about opportunity. And the key to this opportunity will be renewable power. And we will need a lot of this renewable power. So renewable power is what we would call a substitution. We're basically replacing thermal power generation with renewable electric power generation. Today, we have about 16 terawatt hours of thermal power generation. And if we can replace this, we will already be beyond the 10.5 deficit that we have of CO2 emissions. So in general, to say every kilowatt of renewables that we produce avoids 0.5 kilogram of CO2. But today, renewable power is only at the starting point. We don't produce enough of it. The largest production is hydropower, followed by wind, solar, and biomass, which is basically recycling over the natural cycle fuels, and geothermal using the Earth's heat energy. The renewables today make less than 5% of the world energy, and the world energy consumption is huge. It is around 600 exajoules in 2021. This means next to the 16 terawatt hours that we have to replace, we need another 150 terawatt hour of renewable power so that we can meet today's demand. A huge opportunity. At MAN Energy Solutions, we have worked on concentrated solar power plants. For example, here a 50 megawatt plant in Spain. We also produced biomass power plants, as here in Finland, using biomass as a fuel, as well as geothermal power plants in areas where the Earth's activity or the heat of the Earth is close to the surface, such as in Kenya and Indonesia. Another area that has huge opportunities are heat pumps. We just have to think about that heat is everywhere. It's just not at the right temperature. And to get to the heat to the right temperature that we need a very large part of the energy that we use today. This is almost a third of the energy used today. What we also have to say is that today, 21 exajoule of heat is produced with renewables, and the remainder all goes with fossil fuels. And over half of this heat is below 180 degrees Celsius, which is a temperature which is well within the reach of heat pumps. So heat pumps represent also a key to decarbonizing our energy supply. Together with renewable power, heat pumps provide carbon neutral heat. Technology for heat pumps is available in all sizes, from the small 3 to 10 kilowatt heat pump to the large industrial heat pumps, like the one we supplied to the city of Esbjerg in Denmark to take 14 megawatts of renewable wind power and convert this to 50 power of thermal output for district heating using environmental heat from the ocean. The operating costs today are lower than conventional boilers, especially when we consider prices for CO2. They are today in Europe far above 40 euro a ton. They average currently around 80 to 90 euros a ton. The only drawback is this is a technology that requires a higher initial investment, but the paybacks for this higher investment can be done in a short time, between 5 and 7 years, depending on the cost of electric power. Another area is simply hydrogen, green hydrogen as a fuel, green hydrogen as a method of storing energy as well. Our sister company, H-TEC, is ramping up their electrolyzer stack production to meet the demand, the future demand for hydrogen production, which when we read the news there are many plans for large-scale hydrogen production facilities. While H-TEC provides hydrogen, our facilities in Deggendorf provide process and equipment that can convert this hydrogen into green methane or green natural gas. And this example here is a gas production plant, synthetic natural gas production plant in Werple, Germany, where the CO2, carbon dioxide from a biogas plant, water treatment plant that produces a lot of CO2, is combined with hydrogen to produce methanol in a methane reactor. This plant has been in commercial operation since 2013 and can be readily scaled up when hydrogen production takes off in the future. Next to renewable methane, we can add just a couple of molecules more of oxygen and hydrogen, and methanol, liquid methanol, is a fuel that can be used in many combustion engines, but also can be used as a feedstock for other synthetic fuels. The technology is proven based on syngas plants that we have built in the past using natural gas to produce the syngas. And the efficiency is also acceptable with a good conversion in the methanol reactor. And the usage of this methanol is very diverse. It is a base chemical for many end products in pharmaceuticals, cosmetics, paints. But here in this case, this plant that was built in Chile, getting the CO2 from direct air capture out of the air, hydrogen from electrolysis into methanol synthesis plant by our Deggendorf facility, and then finally in a methanol to gasoline conversion to produce renewable gasoline to power cars. Green ammonia does not emit CO2 since it is only a chemical compound made up of hydrogen and nitrogen. The synthesis of green ammonia is well known since decades, and previously the hydrogen for this ammonia synthesis was basically provided by steam methane reforming of natural gas, where the CO2 was emitted and then going into the process. We replace this step with renewable power and electrolysis, and then we produce green hydrogen, and the downstream part of this process basically remains the same. So an ammonia plant of this size, for example, producing 1,100 tons a day of green ammonia, would require 180 tons per day of green hydrogen and 820 tons per day of nitrogen coming from an air separation plant. We have enough of that in the air. And about 11 gigawatt hours per day from renewables to power the electrolysis and the air separation plant. And the uses of ammonia are very diverse. It can be used as a fuel in the shipping and maritime industry. It can be used as a hydrogen carrier, meaning as a method to bring hydrogen from one place to another, where at the destination, the ammonia is cracked, meaning basically heated, so that the hydrogen is released and the nitrogen can be rejected back to the atmosphere where it came from. And finally, also ammonia is the basis to produce urea as a fertilizer, which is also important. We have to feed the world of the future as well. Urea having the additional advantage of needing also purified CO2 from another stream, from an industrial stream, excess stream, to be produced. We also are now going more into the area of avoidance through efficiency. Efficiency is something that, well, we can have the highest efficiency if we let an engine run in its optimal sweet spot, and varying the loads over battery storage so that we can still operate the ship in the harbor or during crossing of the harbor and high seas. If we can run the engine at the highest efficiency, that also directly means lower CO2 emissions. This engine can also be powered by ammonia, meaning then it would also be green, and with the additional benefit of being able to produce this power at a better efficiency. There are many examples where hybrid batteries are in operation in the maritime industry, and this is one of these examples for Seaspan ferry with gensets, 2 gensets and hybrid battery propulsion system, and a cryogenic fuel system, since this is powered by natural gas. Flare gas recovery. Methane is also a greenhouse gas, and our factory LNG valorizes remote methane sources by producing LNG, removing this potent greenhouse gas from the atmosphere that can be then transported to urban areas and put to use productively. These are standardized modules so that the package can be produced at low cost with low execution risk. They're scalable since a number of packages can be added on as you go to meet demand and supply. They're compact in terms of site space so that they can be located and make good use of the land. And we target with our compressor that is here inside a hermetically sealed compressor on magnetic bearings, almost zero maintenance over a 10-year cycle, since we do not need a lot of the utilities that are associated with maintenance, such as oil systems and so forth. And this type of compressor, this Hofheim compressor, is also very well suited for remote operations, since we use this design also in subsea environments. Okay, it's portable, can be transported by conventional road and ship, and because we commission these in the factory, we can assemble them very quickly. Heat and power plants. This is a very well-known method to improve efficiency by not only looking at producing power, but using the associated heat in many industries. And we can also, and let's not forget, that our existing industrial infrastructure will be needed to create the future infrastructure. So why don't we optimize its performance? It's simple. It's a low-cost method to reduce carbon dioxide emissions. In this re-rate case, we were able to reduce power consumption by 5.6%. Now, if this power is produced in thermal power plants that typically only have a 40% efficiency, that turns out to be a 14% reduction in the CO2 emissions to drive this axial compressor. And every improvement counts. Every improvement counts that we can keep our existing industrial infrastructure running efficiently to produce the future infrastructure. So now we come to balance. Renewable production doesn't follow consumption. So we will have to balance this over the days and seasons, but we will also have to balance energy consumption regionally. So we want to balance power over time and geographically, simply because wind and solar do not follow demand, and that this variable power production combined with variable consumption threatens the electric grid stability. So long duration storage is essential. Today, this long duration storage is mainly hydropower, over 96%. And hydropower has geographic constraints. It can only be done in certain regions of the world. So other forms of storage must be considered to balance these fluctuations. As you see on the graph on your right-hand side, each technology has an area where it has its justification. We do need capacity very quickly in terms to be able to regulate frequency in the grid with supercapacitors, with flywheels, and then what goes above what is a couple of seconds, there are chemical lithium ion, but also flow batteries that are best suited. Flow batteries even for longer duration storage times. These chemical methods of storage are quite expensive in terms of manufacturing, also emit a lot of CO2 just to manufacture these batteries. Other types of storage, thermal storage, can be done with conventional methods, and they have a much longer lifetime than chemical cells in batteries. And this is the area where we at MAN are concentrating on liquid air energy storage and compressed air energy storage, molten salt storage, as well as electrothermal energy storage. And finally, also geographic balancing is necessary. Simply, areas with a lot of renewable production are not within the reach of consumers. And this is a very large opportunity for many countries that are situated either in coastal areas or in areas with high irradiation, such as Chile, South America, Morocco, Australia, many areas. And we have to resolve this geographic imbalance of demand and supply. So at MAN, what do we do in this area? The electrothermal energy storage is a tri-generation energy storage system. Mainly meaning we make use of heat to produce electricity, and with the heat pump on the other side, while we're doing that, we have to reject a certain amount of heat as below atmospheric temperature as cold that can also be used in the industry. And given storage of given hot storage and cold storage, we can make flexible use and better use of energy in the different areas of electric consumption, usage of heat, and necessity of refrigeration. Then a system which is focused on energy storage, electrical energy storage solely, which is liquid air energy storage, is a long duration storage technology making use of on one side, the low temperature of cryogenic air, on the other side of a high temperature reservoir provided by the compression heat during the charging cycle. And finally, during the discharging cycle, the liquid air is heated and vaporized using the compression heat then to provide electric energy when it is needed. So in the first step, we use energy for compression and liquefaction of the air. In the second step, we store and wait until the electric demand has changed from a supplier's market to a demand market, and then we can produce electric power by an expansion turbine. Another form of electric energy storage is using molten salt storage. Molten salt is used for heat storage and heat transfer because we can store it at a very high temperature, over 500 degrees Celsius, and thereby we have a high cycle efficiency because we can store this heat at very high temperature. The heat can come off a solar power plant. It can also be generated with a high temperature heat pump using waste industrial heat. And the idea is to use electric power for a heat pump to produce heat, store it in molten salt, and then shave the peaks of renewables when there are excess renewables, and then to produce power from the molten salt, just as a concentrated solar power plant does during periods of low electric demand. Finally, there's also compressed air energy storage. There are a number of plants in the world using this method as well. It always starts out with a period when electricity is abundant. We compress the air. We use the heat of compression and put that in storage. The compressed air is stored in a large cavern. And finally, when the tides turn and power is dear, then we reverse the system, use the air, the compressed air from storage, reheat this air with the compression heat to expand then in a power generation turbine and produce power. And finally, the last item on our agenda is the one that we can't avoid because we simply produce too much carbon dioxide. We'll have to capture it. Some of it will go to use as our hydrogen economy progresses. More and more of this will go to use, and a lot of this will also have to go into storage. The capture path is there's a number of elements in this chain. Is that we have large emission sources that emit CO2. These large emission sources, such as cement plants, steel mills, petrochemical plants, can be purified, what we would call them capture the CO2 so that we have a purified CO2. Some through absorption, some through membranes. There are different types of technology that are all being in research. The absorption technology with amines is the most technologically mature, and there are a number of plants that have been built using amine absorption to then produce purified CO2 that can be then compressed with one of our compressors so that we can then transport the CO2 either through pipelines or through ships, or we can then bring them to a point of utilization where there's sufficient hydrogen and renewables available, or finally put this into storage. The share today is a lot of this will have to go to storage in the beginning and very little into utilization. And the technology for this compressor and its integration with the amine absorption units so that we can reduce the total energy consumption of the system is the topic of another seminar of this digital seminar. I don't really want to go here into too much detail, since this will be also the topic of Peter Klotzsche in this seminar. But these integrally geared compressors are well suited for CO2 compression because we can change the rotating speed of the impeller, so we improve the efficiency. We can also use the compression heat for the amine absorption unit and thereby improve the efficiency at the point of capture. So let me finally round up. The summary is, well, it's easy as ABC. We have to think first about avoiding CO2 emissions. Then we have to find ways to balance our energy supply so that we can avoid these CO2 emissions. And finally, there's so much CO2 being produced that we will have to capture the CO2 for use and sequestration. And a small video before we, at the end, to bring us in shape for the future. Oh, thank you for listening to CO2, something as simple as ABC. We also have a white paper that's available on our website that you can download with essentially this seminar in paper form. And finally, thank you very much and have a good day.
Hi, my name is Mahsa Atyabi. I'm a simulation engineer in turbomachinery at MAN Energy Solutions in Oberhausen, Germany. I'm excited to share with you some interesting functionalities of our digital products, including dynamic process simulation and ritual commissioning, and perhaps to give you a better perspective of what we actually do in our team, Intelligent Automation Solutions. Feel free to type in your questions in the chat box, and they'll be addressed later on. That said, let's get started. As for the agenda, I'll start off with the dynamic simulation, then we'll move on to virtual commissioning. We'll wrap up the session with a live demo in the simulation platform. Dynamic process simulation is all about using a computer program to model the time-dependent behavior of a system, for instance, during startup or shutdown. And dynamic interactions between process components and controllers are analyzed, and the result of simulation provides an immense support during the initial design phase. But you may ask yourself, what's the benefit of performing dynamic simulation? Why stakeholders should invest in dynamic simulation? What might happen if dynamic simulation isn't considered right off the bat in the design phase? Key benefits are to determine the startup curve, to simulate load and acceleration torques dynamically in order to select a motor sizing suitable for the application. Dynamic simulation ensures that the drive concept can provide enough torque to meet the needs of the application. It also helps stakeholders to select the most energy efficient and cost-effective motor possible. For shutdown, it confirms the compressor operation and addresses the concern whether surge occurs at all or not, and validates the SOP calculation. It also provides an immense support during the valve design, like CV value, how big a valve should be, if it's to avoid oversizing and undersizing, and strike time of the valve, how fast a valve is opening up or closing. And to optimize controller setting parameters like PID controllers, proportional, integral, derivative parts. We'll get into this part in more detail during the live demo. Basically, there are two methods to describe the behavior of a dynamic system. Analytical method using the differential equations, and database method using neural networks. Using analytical method, the model is based on thermodynamic equations, heat and material balance, mathematical methodologies, to the extent that the model could reasonably represent the actual plant in the real world. Modeling of flow dynamics in pipes is based on equation of motion and equation of continuity. Variables like cross-sectional area, length, diameter, temperature, inlet temperature, pressure, and gas compressibility, they're all inputted into the model. Compressor is described by its performance map, polytropic head versus flow rate. The head can be calculated with this equation. And at the end, basic calculation for valve follows this equation. As you notice, in order to find the max flow rate, CV value, pressure inlet, and temperature inlet, density are all inputted into the model. Just to sum up, differential equations are used to describe the behavior of the overall process. As for the database method, I've got you two decent examples. In the first example, you see that the real compressor dataset is used to train the model. It's using machine learning tools like artificial intelligence to predict the compressor behavior. The AI-based compressor model is then embedded in the simulation library and is used in the simulation later on. In this study, we use the compressor model as a case study to illustrate the comparison between the analytical model on the left with the AI-based model on the right side. We found that the predicted results by AI in green, even in dynamic mode, have a good accuracy when compared to analytical model in red. It can be concluded that a simple recurrent neural network can fully replace the analytical model, and plus side is the reduced efforts for AI-based model development. Second example is for heat exchanger. To compare the analytical model on the left, again, with the AI-based model on the right. You see the calculated outlet temperature of heat exchanger in red and the predicted one in green. Deviation between the two models are quite negligible. Feed-forward neural network is combined with monitoring network to ensure reliability. So to sum up, dynamic simulation models are like digital twins of the plant. We see the process components like pipes, flaps, valves, compressor as are in the real world. They can be used to simulate the dynamic effects of a process and the behavior of the plant. With such models, we improve our understanding of the process without having to disturb the actual process. They can address a lot of what-if scenarios and questions. Depending on the project specification and client's requirements, we select a suitable simulation platform. Here you see MATLAB Simulink simulation platform for an air separation unit application. It is an in-house tool developed over years of extensive experience. The process behavior is represented in the classical approach using analytical method, and simulation model is then parameterized and inputted with gas and component properties like valve, pipe, motor datasheet, compressor maps. At the end, initial operating points are defined, for example, starting from SOP, settle out pressure, or shutting down from normal operating point. Process components are in the model, like different types of compressor, axial compressor, radial compressor, pipe volumes, different types of valve, flap, and driver, here is steam turbine. Or another simulation platform developed by H-TEC is called HYSYS. Same procedure as in Simulink. It's a classical approach based on analytical models, and the model needs to be parameterized with some variables, and initial starting points need to be defined. Again, we have different compressor types, like here we have 2 stages on the top, 2 stages at the bottom. Then we see the heat exchanger at the suction part. And so heat exchangers here. Then the pipe volumes. And on the recycle line, we see the anti-surge valve. So the recycle line from the discharge of the compressor back to the suction. And the suction scrubbers at the inlet of the compressors. So far, we've built up the model, we've inputted the model, and now what's the outcome? Dynamic simulation provides a higher level of process analysis compared to steady-state condition. In steady-state simulation, process conditions remain unchanged over time. But in real world, we know that things are always changing. At one time, we get the order to shut the motor down because of some sudden pressure fluctuation upstream the process, or the unplanned power outage, or like a malfunction of a valve. As we see here, not only the process, the movement of the compressor operating point is shown in the compressor map, but also we see different process properties like mass flow and the pressure, temperature over time. So we can see, for example, the change of rate of pressure over time, and the gradient of pressure, or like for speed, for mass flow, for power. So in the graphs, you see how the process properties change over time. And that's one of the benefits of dynamic simulation compared to steady state simulation. Now we get to virtual commissioning. Commissioning is the setup and ramp of the control system implementation for automation. Virtual commissioning tools let you develop, test, optimize commissioning early on, during the planning and design in a virtual environment, before production start, before connecting to the real system. The aim of using virtual commissioning is to allow for early validation of machine operation. But what are the key benefits? Implementing virtual commissioning shortens the overall commissioning time. It enables higher quality software before FAT, factory acceptance test, and SAT, site acceptance test. During conventional commissioning, not all the problems can be identified and fixed. In the virtual one and the simulation model, much more can be tested because the overall process can brought up to critical conditions and several what-if scenarios can be safely simulated and tested. This leads to a higher software quality. There is this huge advantage of correcting and tuning the controller setting parameters. There is a strong foundation for predicted future plant optimization, and we can train plant operators and commissioning engineers to run complex units and deal with emergency situations. Each time a plant is commissioned, the control software is tested in terms of logic, shutdowns, step change, control secrets. Errors that are discovered at this stage cost a lot of money and time. Virtual commissioning prevents this challenge. But the question is how? Instead of using the real plant, the control system is coupled with a simulation model which represents the actual plant. It uses highly accurate digital twin of equipment like PLC without any risk to the real facility. Since virtual commissioning can minimize the occurrence of faults and errors during the process of commissioning, it is a cost-effective way to fix errors while testing the system. Plus, it shortens the time required for final commissioning. So at the end, the modeling and virtual commissioning can be executed parallel with the design and engineering phase, and it leads to saving time and money. So how does it work with the hardware in the loop simulation HIL? We take the simulation model and convert it to CLang, then load it onto special hardware. It is a real-time PC called SpeedGoat, which is based on a real-time operation, and real-time behavior is needed since it will be connected to PLC, Programmable Logic Controller. The original PCS7 hardware is taken and the control software will be developed and uses the original hardware and software. So PLC sends control signals to the model, so like commands on and off for drive, like motor gets off or on, or the set points for the valves, if it's like 100% open, if the valve are partially open, and then in return, SpeedGoat or like the model returns values like feedbacks back to the PLC, values for pressure, temperature, flow, valve position. We have already this setup available in the office. Just to give you a picture how it looks like, there are essentially 3 components involved. The laptop on which we have the MATLAB Simulink installed on it, and the simulation is executed. Then we have the real-time machine, which is called SpeedGoat, and the PLC, which is a PCS7 CPU. The first two, laptop and SpeedGoat are connected via Ethernet, and SpeedGoat PLC have this Profibus connection. So how does it look like in reality in the office? It's like in a rack. So we have the SpeedGoat computer connected via this Profibus cable to this CPU. Now we'll get to the live demo. Here is the simulation platform MATLAB Simulink, and we see the air separation application, the compressor part, some of the process components, the axial part here, radial part here. Then we have different types of valve, the non-return valve, and butterfly valve, blow-off valve. As for the drive, here's a steam turbine. And just to give an example for one of the pipe volumes, parameters like length, diameter are given. And under each of these ones, there is a mask. And for differential equations, again, we have the gas compressibility, the gas constant, and isentropic exponent. Same thing for the compressors. Inside the mask, we see the compressor map also given to the model. As for the controllers, we do have this anti-surge controller and pressure controller. They are all integrated in the simulation platform. The case which we are simulating here is the rapid changing of the process resistance due to the closing of the valve. And it results in the compressor operating point moving towards the control line and the surge line. For the purpose of this session, we have two case studies. The first case study that we have is when we have the wrong controller setting parameters, and we'll see what happens when the controller setting parameters are not well parameterized and tuned. So I'll maximize the figure. On the top, we'll see the compressor maps for the axial part and the radial part, head versus flow. And then, the green line is the controller line, red one is the surge line, and the blues are the compressor operating point, which is now moving towards the control line. Here we see the discharge pressure changes over time, and at the bottom we have the controller output for the anti-surge controller, the blue one, and the pressure controller, the pink one. We'll see after some seconds, the reaction, the behavior of the compressor operating point within the map. If it keeps the operating point within the safe region on the right side of the red line, or does it get into the surge with the wrong controller parameters? It's just to show that the behavior of the overall process in a dynamic mode over time, and scenarios like startup, shutdown, they can all be simulated and addressed in dynamic simulation. So we'll see it here. So see, because the controller parameters are not well tuned, the compressor surges, and we'll see another example. The second, I'll have to stop it first and close the picture. The second case study is regarding the same model, but what happens when we have the controller setting parameters are correctly parameterized. So you see that all values are changing over time, and we'll see the plot after 5 seconds. Although it's not in real time, it shows the transient behavior of the process. Yeah, so we'll have this all controllers reacting. Yeah, it shows the movement of the operating point within the map. That's the benefit of doing the virtual commissioning, because you can tune the controller setting parameter well ahead of time and see what's the best for this application. So it just needs another 10 seconds, something. Yeah, just getting closer to the control line, and we'll see the difference. Yeah, we'll see that the controller, because it's correctly tuned, it's able to keep the compressor operating point within the safe area, and it avoids surge. So the point is not moving to the left side of the surge line. Perfect. Yeah, that was what I wanted to share with you. The key message of this presentation is that with the aid of dynamic simulation and virtual commissioning, we can validate the overall design and to avoid over-design and oversizing. At the end of the day, it comes down to minimizing the cost and maximizing your profit. For further questions, feel free to visit our virtual rooms. My colleagues are there to answer your questions. Thank you. Have a good day. Bye.
to this session about turnaround solutions. My name is Oliver Tromm. I'm heading a product center within MAN Energy Solutions, and I'm accompanied by Simon Arzt, who is heading the field service department in Zurich.
Hello from my side as well.
Very good. Thank you, Simon. We would like to lift your next maintenance intervention, your turnaround, into a turnaround solutions. And we would like to explain a little bit to you what turnaround solutions mean to us.
So, Oliver, when should the customer turn to MAN for a turnaround solution?
For me, it's pretty obvious. If a customer is not looking for a transactional relationship, but is trying to make everything or to give everything in one hand, in one contract, with minimum interfaces, with a lot of coordination work within one hand. That's one reason to do so. On the other hand, MAN brings a lot of expertise on the table. So where expertise is needed that the customer doesn't have, that's an argument or a reason for that. And the last reason for that is, and that's more coming from the minimum interfaces approach, is that you have a tight schedule because you cannot lose time in interface problems during the execution, for example. So timing reasons could be a reason to turn into a turnaround solution.
Definitely. So my proposal would be we give Sven a call. He works for MAN Qatar in Doha, and he can share his experience from the last large turnaround which he had. So we quickly organize the call.
Hi, Simon.
Hello, Sven. This is Simon and Oliver from the Digital Summit.
Hi, Oliver, too. How are you?
Very good.
Sven,
excellent.
could you share your thoughts and experience from the last overhaul and large turnaround which you had in your region?
Yes, Simon, of course. Yes, thank you very much for the question. And as you know, one of our main customers here in Qatar has 8 air separation units or ASU trains. And each one of these trains is made up of our steam turbine, and on the one side of the turbine we have our main air compressor, and then through a gearbox on the other side we have the booster air compressors. And then of course we also have 4 additional recycle gas compressors in the liquid processing unit. That's just as a background to make you understand the size of this plant. So for this major turnaround at the beginning of this year, effectively half the plant was stopped, meaning we had to work in this case on 17 different casings, covering the ASU units 1, 2, 3, and 4, as well as the LPU plant. So the most complex task was really securing the correct manpower for this massive scope of work. And then when you throw in COVID, complications with the government, restrictions, etc., you could say that we were really, really stretched at that point. You need to remember, of course, GTS is only a small team with less than 60 people. But during the shutdown, we grow close to 200 people. So suddenly we've become a major contracting or project company. Now, the complexity around the project is that each machine will have its own detailed scope of work around which we have to plan specifically. We cannot say that one steam turbine is exactly the same program as the next steam turbine. So the most important factor for success is really in the step-by-step minor detail planning. You have to ensure that everything is planned correctly together with the customer's own contracting team to make sure that you have the right tools, the right spares, the right people, the correct cranes, etc. Everything in place at the correct time, and also that you have enough space to conduct your scope of work within the overall shutdown schedule, because you need to remember, from the customer side, there are also thousands of contractors on site at the same time. So planning this effectively takes 1 year before you can actually start work on site.
Understood. And what were the main obstacles you had on this turnaround, and how did you overcome them?
Well, as I already alluded earlier, I think the main obstacles in this particular case were perhaps a bit more different to a normal case. And by that I mean the numerous obstacles that were rolled into our path pretty late during the planning phase, and that was the government policy around COVID protocol. The government requirements kept on changing on a weekly basis, which wreaked complete havoc with our manpower deployment. We have to deploy people from right across the globe, even without Corona. Imagine having to bring candidates from the Philippines, India, Sri Lanka, Germany, South Africa, UK, and Brazil. This was by far the biggest obstacle. We realized, luckily, fairly early on, that this really called for what I would say, a supersized HR and project execution team, which would not have been managed by the local team. So we got in some experts to assist us right on the onset, and we had to bring the correct people, we had to ensure that we eventually end up with the correct people here on site. And of course, the second obstacle is working together with the customer and the SIMOPS team, the simultaneous operations on site. The goal is to have all the work completed in the given shutdown window, but also optimizing on the maximum number of staff on site at any given moment. You want to remain as consistent as possible with the smallest team as possible, yet they need to, if at all possible, remain fully utilized throughout the entire shutdown. And then this has to tie in with the customer's other operations on site or the remaining plant that needs to be serviced. And you can really only achieve this if you have formed a good team with the customer and all the other stakeholders right from the onset.
Very good. You mentioned several times the interaction with the customer. How happy was the customer afterwards? Can you share a little bit the feedback or the recognition of your work done?
Yeah, so we're actually pretty proud to say that we received excellent reviews from the customer. Compared to other contractors on site, we were by far one of the most successful teams on site. We were even asked by the customer to assist them on one of our competitors' brands' equipment during the shutdown, and even managed to stretch ourselves to accommodate that extra mile. But however, as with all such jobs, there are many things you learn during the execution, and for sure, even here there were many areas where we could have been better and where we need to improve. And this was, of course, also determined afterwards, formally during our post-mortem or post-shutdown, post-mortem, together with the customer. We have learned many small things where we could have done better on both sides. So in summary, you can really say, again, I cannot repeat this enough. This success can only ever be achieved if you form a great team together with the customer right at the beginning of a big project like this.
Sounds very logical.
That's it in a nutshell.
No, very good. Sounds very logical. Thanks for sharing that. And I know that you are in preparation for the upcoming outage again with your customer, and it seems that the customer shows proof in returning to you and contracting you again for a similar scope in the future. Thank you, Sven, and well, thanks for joining in today.
Greetings to Doha. Bye-bye.
Thank you very much. Yes, and all the best from Doha. Have a good afternoon, guys. Good evening.
Cheers. Bye.
Bye-bye.
Thank you, Sven, from Doha. It was a very nice explanation on from the field side as well. But then the question is, we have talked about when a customer should turn, but why should a customer turn especially to MAN Energy Solutions for a turnaround solution? So,
yeah, the big advantage is that we only have one interface and therefore also bundled responsibilities. That means you have the single point of contact for all the equipment, including the peripherals which are in the scope. And for sure, this helps then in the job preparation because we have the site visits with the project management. We can do the scheduling for all the scope which is included. We do the contracting, the planning. We are responsible therefore also for the HSE, the quality and the logistics management. And for sure, we are able then to discuss all technical issues and to clarify with the customer upfront the expectations, and also in order to gain the trust that the customer relies on MAN to execute the large turnaround.
And how do we secure that? This is a big question which always comes on the table, and we are working with dedicated project managers, which are responsible for also in the preparation phase, but also in the kickoff meetings and all alignments with subcontractors, for example. And they are taking care of this integrated schedule, which I've mentioned before. So project management is one key element. And the second thing that we are taking care of is the site preparation, because logistics and all the permitting things. And so this is extremely important that it works seamless and in a very controlled manner. Because like Sven was saying, customers are expecting minimum downtime or maximum uptime, so to say. Very good. So I would like to call another specialist, which is Adriana. She is a project manager from MAN North America. And I would like to ask some questions to her as well. Could you establish the line?
Try.
Hello, Adriana.
Hello, Oliver.
Hey, Adriana. Good to have you, and welcome to the session with Simon and myself during the digital convention.
Thank you.
Well, thanks for joining. And we were just discussing, Simon and myself, and giving a presentation on the large turnaround and a little bit about the expertise and how important project management is. You as a project manager in the MAN US organization, how have you set up in your last project the project management team successfully?
Well, for the last project team, this project based on the special necessities and challenge that this project presented, we decided to form a multidisciplinary team in coordination with engineer solutions from the PC warehousing. So we defined specific functions and roles for each team member in order to reach the target and provide the best solutions to the customer. So both the PC and locally in the US, we work on close connection and coordinated where we could provide any technical requirement coming from either the end user or even our internal field service personnel that is in fact right now working on site.
No, very good. Thanks for sharing that. And it sounds like, and we have talked about that, how important preparation time is. For this specific project that you are talking about, how long was the preparation time taking?
Well, the planning phase has been one of the main pillars on this project. Both customer and MAN, we have invested a lot of hours on internal communications, meetings, and site coordinations, where we work together, making and establishing a clear agenda and defined strategy. Thanks for a very clear commitment from both parties on these projects. We have strengthened our relations with the client, which have kept us very motivated and support, and which help us also to generate important business with MAN in the upcoming year for this same project.
Very good.
So we can say the interaction with the customer, how close is that? Can you describe that? Because I think this is a very important issue.
Oh, as pretty much I mentioned before, the clear and open communications from both the customer and MAN is what has established a very good relation and have eased our streamline to support each other. So we have a very clear and open communication with the client. Also, with all the team members, project manager, on-site coordinator, field service team, sales manager, we all are working towards the customer at a single unit. So customer really appreciates MAN support for all these different disciplines, both locally in the US and with our support from this PC.
Excellent. Thank you for this short presentation of the project. And thank you, Adriana, and goodbye to Houston.
Thank you, Simon and Oliver.
Thank you, Adriana. Bye-bye.
Bye-bye.
Bye.
So we have discussed about the upfront of the turnaround, the plan and prepare of the upcoming turnaround, assignment of the dedicated project team, the pre-arrangements on site, and now we come to the execution of the project management. This means we have the dedicated project manager, as we just learned from Adriana. And we have the highly specialized field service personnel from ourselves, from MAN, as well we have the HSE and quality officers, as well as all the subcontractors on site then to execute the turnaround. We also have the back office support with dedicated engineering resources, which is very important because we have to have solutions for planned and unplanned repair and revamp activities also. I would like to just point out that in the Digital Summit, you will find also information about our workshop network, which is available. So we normally step back to all the resources which we have in order to execute the large turnaround as fast and as the quality requirements to the customer. We have also the engineering resources in-house for sure. That means we have turbo machinery repair, upgrade competences, reverse engineering. We have all disciplines, mechanical engineering, electrical and control systems, thermal, rotor dynamics, and all the other engineering in order to support the large turnaround.
Very good. Thank you very much. Because and Simon pointed on this one already. I think the competences for the project are extremely important. He highlighted that you should also watch out for the shop network and for the individual introductions of what you can expect where. But on the other hand, he also highlighted the engineering competences. And when we talk about not only the project-related, directly project-related competences, we also have to look into the maybe not so obvious directly project-related competencies, which are, for example, handling the HSE issues. HSE is an extremely important topic, not only for MAN, but also for you, because environmental issues, but also safety needs to be taken care of by professionals. MAN is extremely experienced in that. We are not only doing these kind of turnarounds, but we are also doing the large erection works when it comes to delivery of a turbo machinery equipment. And with the HSE discussion and with the risk analysis based on that, you have automatically a risk mitigation element into your scope of work. And this is what MAN brings on the table here. And last but not least, I would like to point out, because that's also partly HSE related, because when we handle material, lifting of material and also the logistics behind it bear certain risks. There's lots of documentation required, but there's also an expertise that is needed in order to have a trouble-free or a flawless execution of the project. And in order to demonstrate a little bit how complex projects of that could be, I would like to invite you into a quick example here, which is coming off from an oil refinery.
Yeah, as you mentioned, we have made and executed many large turnarounds in the past, and this is one of them. We just bring this as an example because there was the challenge that we had to work with many different brands like GE, Mitsubishi, Elliott, Turbimac, Cameron, and G. In order to make the overhaul on all these turbo machinery trains and auxiliary systems like the gearboxes, oil systems, control systems.
Very good. And you mentioned the scope of work, and the boundary conditions were perfectly in line with what MAN can handle properly. There was a big expectation from the customer side on the scheduling and on the on-time completion, but also there were some specific requirements on what kind of personnel you need in terms of, are they allowed to come from a sub-vendor base, but or are they just allowed to be MAN employees? In this case, it was 100% MAN personnel and the requirement of 100% local content. So if this comes into play, MAN is your right partner with a global footprint as we have it today. And specifically, I hope this disappears in the future, that we have to mention that as a challenge. But this project was also executed under COVID scenario, which for us is giving an additional headache. But since the project was executed well in time and in cost, I would say it's manageable.
Definitely, yeah. So when we come back to our sequence of turnaround solutions, we see that after the turnaround, there are also important steps to be thought of. That means when we have executed the equipment or the turnaround and the machine is running again in industrial operation, we do the spare part management for all the service equipment as well as for the peripherals. We do the documentation. the performance measurements, vibration analysis, and inventory management. And for sure, we do the spare parts recommendation, so you're prepared to operate the machine in the future. What we offer as well is then to digitize the equipment for preventive maintenance. Therefore, also please visit our digital summit for the other topics like Prime Surf Assist, where you can see how the machines are monitored and how we give actually recommendations how to improve the operation of the equipment. We do the digitalization of the plant, which is kind of a Google Street View, where you can walk through the plant and therefore facilitate the planning and also the maintenance of the plant. Therefore, also we have a separate session, and for sure we connect you to the H-TEC, where we are able to give you a support, which is also available in the digital summit.
Very good. Thank you, Simon. And I think that brings us a little bit to the end of the session here. Thanks for listening. I was extremely impressed by the last points because turnaround solutions or turnarounds do not mean maintain, but also to digitize the activities, but also digitize your equipment. And I think that's a perfect match to the digital summit as we're having it in these days. Thank you very much for joining.
Thank you from my side as well. And please rest assured that MAN is the right partner to execute your next turnaround.
Thank you.
Thank you.
Good morning or good afternoon, dear viewers, wherever you are located and wherever you are watching us. Welcome to the Digital Industry Summit of MAN Energy Solutions and our panel discussion on digital, or to be more precise, on the proceeding digitalization of the economy and our industries. My name is Michael Melzer and I have the pleasure to be the host of this panel. I'm a communication specialist at MAN Energy Solutions and a typical user of digital tools, of course, but I'm certainly not a digitalization expert. Very much contrary to my great guests and fellow panelists, which I would like to introduce to you briefly. And I would like to start with Paula, which sits right next to me. Paula Doyle. Paula is the Chief Digital Officer at Aker BP. Our next panelist is Chris Marcus Kretz. He is Director Automotive at Amazon Web Services, where he's heading the Global Account Unit. Before he joined Amazon AWS in 2016 to develop the automotive and manufacturing vertical, he had gained 15 years of experience in various sales and management roles at IBM. Welcome, Chris. Let's move on to Sascha Wenzel. Sascha is heading the asset management and digital products business at thyssenkrupp Uhde. His area is in charge of assessing plans to provide the information gained to the customer and to recommend performance improvements with regard to operations and maintenance. Sascha has been with thyssenkrupp since 1998 and has more than 20 years of experience in the refining and petrochemical sector. Also a warm welcome to you, Sascha. And last, but certainly not least, right in the middle of our panel, we have Gregory Puckett in our discussion round. Greg is the Chief Digital Officer at MAN Energy Solutions, driving the digital business and ecosystem to serve our customers. He's a digital native with technology and business roles spanning 25 years of experience within big established companies as well as within startups. Welcome, Greg. Dear participants at the screens, I'm sure you agree with me that plenty of expertise has gathered in this panel and that we can look to a great and very interesting discussion round. I'm at least very much looking forward to it. So let's start. And yeah, my first question goes to you, Paula. What are the digital trends and business imperatives for the industrial sector and to have industrial as a general topic?
Yeah, I think that's a great question. And maybe I should just take a second to explain who Aker BP is. So we're Norway's second largest oil and gas company and one of Europe's largest independents. And I think we're very much on a mission to transform the oil and gas industry. And for us, I think when it comes to digital, it's really an enabler for us to hit our kind of strategic ambitions, which is low cost and low carbon. And I think with digital, it's always really important to focus on like what are the business outcomes you want, because it is one of the tools in the toolbox. So we don't do digital transformation for transformation's sake or for digital's sake. We do it to kind of have a better business. But if you look at some of the trends, so some of the technology trends, because I think we're living in a golden age now of technology. If you look at the last kind of years before us, say the last decade, you see cloud computing, edge computing, mobile connectivity, and industrial robotics have really developed at pace and kind of converged to the point where we have this just really like amazing toolbox of tools from which we will accelerate kind of the industrial adoption of digital. So I'm very excited about that from the business perspective, but also because I'm a bit of a nerd from the technology perspective.
Thanks a lot. Greg, how would you define digital transformation in the industry segment, specifically with regard to turbomachinery business? Because from MAN's perspective, industry segment is more or less turbomachinery. And what does digital transformation really mean for today's business leaders, from your perspective?
Sure. So I think the digital transformation, as Paula said, I mean, we at MAN try to follow the lead of our customer and customer needs. So we're not doing transformation for the sake of the technology, but certainly for reliability, availability, cost savings to drive to zero carbon emissions. So we working closely with our customers, and every customer is a little bit different in what they want, but at the same time, they want high availability. I mean, remember in our turbo machinery business, some of our equipment's lasting 50 years, right? The reliability of the equipment is there. So digitization just helps to drive the optimization. It drives how does the customer optimize the operation of the equipment, either through less manpower or through more operation, less maintenance windows. So I think the digital transformation within the industries, and actually industries is probably one of the most mature segments that I'm working with for digitization, because process data and processes have always been sort of the driver of that. And digitization just kind of allows us to automate those processes, right? And give higher visibility. What used to be a written report now, you can get instantaneous information through digitization. So that's my view from the industry side. As far as business goes, I think it's not about technology, the transformation at all, as Paula mentioned. This is really a transformation of the way we work as human beings. It's the way that we used to do things that takes 5 days to how can we get those things down to 3 days, 2 days, and 1 day. So I think the transformation is the technology. Yes, it's constantly changing, but digital native guys, they live, girls and guys grew up on that, so they're able to respond. But think about holistically as an organization, you have a wide gamut of different folks, and they need to feel they're part of the transformation. So it's really about how does the human tie back to, let's say, the technology versus the technology driving the human. So it's all about the humans, the transformation.
It's an interesting thing, though, isn't it? Because I have people, and I'm sure you hear the same, they say, oh, I don't do digital, I don't do data, as they pull out their phones and intuitively use, AI, cloud, edge. There's something that we need to kind of shake off, that you don't change as a person when you come into work, right? It's the same technologies, it's the same kind of.
But do you think it's because they can't grasp it, right? Because with your phone, it's intimate, it's something you do every day. And when you talk about digitizing an engine or digitizing turbo machinery, are they able to go from the head to the heart there? I think that's the big question with the human nature. So I agree with you. We're doing it every day. I mean, modern cars are also somehow digitized, right? You have an app. You have an app for everything. But for working environment, it is interesting. Do people feel safe to ask the questions?
Exactly, and I think it's something around the way people like you and I are talking about it, and we're trying to talk in a much more relatable way, because before it was very kind of technologies and transformation and very conceptual and hard to actually grasp, whereas if you actually look at kind of how people have been transformed and their processes have been transformed through mobile phones, etc. People are doing it already.
Absolutely.
Yeah. Transformation is not a new thing, right? We just learned it earlier today when we had this magnificent tour here at the museum, where you went from the steam engines to the diesel engines. That was a transformation itself. But what you were talking about is actually, does it have a customer value? Does it have a business outcome and a value to the business? Yeah. That's what digitalization is about, right? If I tie into how we think at Amazon about this, right, we relentlessly focus on the customer, right? And just if things have an outcome and a value for the customers, you do it. Right? And the funny thing about customers, and that maybe answers your questions why in the business sense people think differently than as privately in using their phone, is because customers, the good thing is even they report they are satisfied, they have hidden needs and they want more or get more value out of things than they even can express sometimes, So, and that is something we can play with, right? Even in this cultural transformation that the digital transformation is. How do you take the people along? If it gets a value for you, if it gets a value for the business, then you can take these people along, right? And they don't have to change the way on how they're doing their things or the area of expertise they are in, right? They just have to use it in a different way. They shouldn't throw this stuff away at all.
Right. And it's going from the head to the heart, as I mentioned.
And let's stay with you, Chris. What do you think are the current drivers of the digital transformation? I mean, on a short-term basis, let's say until the end of next year. What do you think? What are the the most important drivers?
Yes, first of all, I think, as you said, Paula, it's a digital age. Actually, we have all tools at hand suddenly, right? And you can just take business decisions or create value for your end customers, and the end customer can even be an internal end customer, by the way, if we talk about internal functions. You have all the data at hand, and if you have insights to the data that you talked about earlier, you can take decisions upon them, and you can act upon them. AI is something on top of it, right? So that's the one thing. The other thing is that the pandemic taught us actually that you can do a lot of things digitally, right? Even how we work and how we interact with each other, how we order, for instance, stuff, but also how we communicate, right? We can do a lot of things digitally, and especially I think that the current global crisis we are on with the war and even with the energy crisis resulting out of it, I think it's actually an accelerator of the transformation. And foremost, and the next step is that it will drive sustainability. Right, and so we, as Amazon, for instance, we think about that in the climate pledge that we have and the fund we invest in, where many companies, and we had close discussions about this as well, how we could collaborate on that. I think this will drive the digitalization as itself, right? It's a catalyst.
Sasha, on a long-term scale, what are the drivers, let's say, from 2024 on? What do you see?
There are several drivers. First of all, I think there will definitely be a technology push. Yeah? So that's what we have also done in the past. Yeah? So we learned some new technologies. We try to also convince our customers to use these technologies. That will definitely continue. And so it can be easy things like 5G, 6G, whatever, but also the availability of the internet in general. Yeah, it's because some of our customers are also operating their plants in pretty remote locations. Yeah, so where we have seen a lot of improvements already, but this trend I think will for sure also continue in the next years, next couple of years. Then of course, secondly, we also of course have a market pull. Yeah, so like I said, we initially tried to convince customers to use products which we had available. Now the customers are asking us, because they have learned from us, but also from other competitors, that certain products are available. Meanwhile, they are requesting us in our conventional business. So when they send us an inquiry for a chemical plant, they also ask what kind of digital products can you sell? Do you have any advanced process control systems and so on? And so there is definitely a need in the market, and customers have also experienced that digitalization comes at relatively small costs compared to the investment to a chemical plant. So that's definitely another aspect. And of course, we have also seen now, especially in the last 1 or 2 years, this green transformation that will impose new challenges also to our current technologies. Because there will be fluctuations of the energy grid and so on, and our processes have to be able to take these fluctuations from the grid, from maybe hydrogen supply and so on. Yeah? And we have also developed some concepts how to ramp up, ramp down plants as soon as fast as possible, which are based on AI and also on advanced process control.
But what you just said, and maybe I can tie this back to the cultural transformation that you said, right? We did analysis with customers and work with customers in the manufacturing industry. And it's not always about that you digitalize the entire value chain at once and you do a big transformational projects. It's the small things that make the difference usually. So if we looked at, once a plant is connected for sure, right, and it's stable and reliable, that's another topic. But like, at the start you tried to measure, is a line down, but you didn't ask why is the line down, and then you come, if you going into the granular things, right, we did an analysis where we digitalized the line very simply, and you saw that some buffers on that production line were filling up, but nobody ever asked the question, why do some buffers fill up which impact another buffer? They just looked at the end result that the line wasn't producing well. In the end, it came out, it was a micro downtime, I would say, because someone did an unintended break, or the shift plan wasn't done well and the worker on the one part of the line was late in that regard. So that's why the buffer was filling up, and that had a consequence down the line. That is also then something on the cultural transformation. You take the people with you, because if you give them more insight and more decision power on where they are, right, you bring them along in the digital transformation.
Because there's no shortage of curious and excellent people in the industry. I think one of the things they're really lacking is the tools and the data at their fingertips.
I mean, one thing to the future of transformation, with the pandemic, as Chris mentioned, and the uncertainty, I mean, do you see in your industry more and more need for remote commissioning, more and more need for autonomous operation, more and more demand for less human interaction? I think that's really going to be those step-by-step transformation.
Sure, definitely also avoidance of routine activities. Yeah? So I think that's really where machines are much better than human beings. Yeah? Because if you do the same action every day or every hour, it's this routine activities which also lead to mistakes sometimes because you're bored or so. That can be handled by machines, maybe more easily and better than by human beings.
And I can tell you actually about we've got a very large greenfield development right now off the coast of Norway. So it's going to be the most complex offshore processing plant that's ever been built. And for us, it's the largest one we've ever built by far. But what we're doing for this one is we're setting the expectations that it will be it won't be fully unmanned, but it will be as unmanned as possible. So if you look at a traditional kind of setup today, you might have 200 beds on the installation. For this one, we will have 40, for example. So, and the expectation is a digital operating model, that allows for things like energy efficiency and optimization, predictive maintenance, et cetera, et cetera. So, and for the first time ever, as well as ordering the physical deliveries, the platform and the processing equipment, we are procuring a digital twin so that we're ready to go even from kind of the EPC stage, so that it'll be built up so that we then have it.
Increasing efficiency, right?
Precisely.
But the job is just shifting. The job of the people, or the people you need for the rig itself, isn't that going away in total? You just shift the profiles to a different profile within the company.
Well, not exactly, because what we're doing, so for example, with the bringing in predictive maintenance, for example, the expectation is that we will have less people needed to do maintenance on the plant. So it's not that we're taking the same people and then moving a lot of them onshore. We will actually, through the use of technology, decrease the amount of human intervention required to keep the plant up.
You can compare it to data centers, right, in AWS. And if you think about 15 years ago, there was the trend for the lights out data center, right, where you had monitoring, where you had less interaction, you had more people sitting in a control room. And it's interesting, you just see that transformation moving into modern day plants that happened in the data center 10, 15 years ago. So I think it's the same trend. You will have different skilled people, right? I mean, who will use different tools. They can be the same people. And, we didn't talk about, as part of the transformation, the reskilling and the repurposing of people, but I think that's also a really key point in the whole transformation.
But before we come back to this people's aspect, saying, okay, culture, skills, talent, and all this kind of stuff, I would enlarge on a topic that I think most of you, if not all of you, mentioned, and that is the green or the decarbonization aspect. Is there a clear link between digitalization and decarbonization from your point of view? And if so, what is the link? Can you enlarge on that?
Absolutely, there is. I think there's no doubt about it.
I think Chris mentioned it with the data, right? Because if you think about whether it's in maritime or any of the other industries, you need data, right, to really tell you how to optimize machinery. Are you operating within certain parameters? Am I burning the right amount of fuel? I mean, data tells the story about everything, and without digitization, you have no data. And I think the data is the first step from the design of a product all the way through its life cycle. I don't know, Paula, maybe you have something to add there.
Yeah, I think it's two ways for the data. So the first one is obviously the data to measure the emissions, right? So that you're actually able to act on sustainability pledges and, of course, pay the taxes that you need to pay, should that be the case. But then I think it's exactly like you're saying, we need to be able to use data to optimize our processes so that we are able to be really kind of best in class at energy consumption and fuel consumption. And it's two ways that we look at that. And this is obviously where we need to work together with suppliers like MAN on the equipment optimization. And then we also need to look at the total process optimization as well, because you can see oftentimes in plants we're running kind of things to bring in a level of redundancy that maybe is over-spec'd. And if we were able to handle a little bit more risk without kind of impacting the production, we could actually really significantly reduce our energy consumption, because industrial plants are big energy consumers. So I don't think we're not there yet, but technology and data is really key.
Getting insights and then also drawing the cross connections between the data and as well the patterns that you find out. I think that's the most interesting thing. If we just think very simply on the October in Germany has been one of the hottest, or it was the hottest actually since we record, but we just record since 100 years, right? So the database is pretty small actually at that. So if you increase the database and the amount of data that you have, and then you analyze this data, and then you can learn from them. And I think that's the key actually for sustainability and decarbonization, to get insights and to act upon it, because there might be even interdependencies that we don't know yet. Right.
But speaking of the interdependencies, I mean, we talked about this earlier, Paula, with the traceability.
Yes.
So we, MAN, as an OEM, we have a pledge, right? And we need to understand from the supplier, the entire supply chain, all the way through, what is the carbon intensity of a product, right? Because you as a customer, to meet your pledge, you would probably have a demand on us as an OEM. So I think, again, digitization is from the design throughout the whole process, because if only operation were the decarbonization factor, that would be easy. But the manufacturing and the design throughout the whole life cycle, I think that's where the data really comes in.
And it's also something
connectivity.
Yeah, but just to say as well, because there can be a conception about the oil and gas industry, which is the industry that I come from. So from an Aker BP perspective, our aim is to be net zero with our operations by 2030, and to be kind of one of the lowest CO2 emitters in our industry globally. So we see the same things, right? We see the same challenges. So we're working with kind of our energy supply as well to try to make a difference.
And beyond decarbonization, which opportunities do you see with a digital transformation?
Well, I think it's everything related to kind of how we can run our business more efficiently, and that's the top line impact in terms of kind of production optimization, our ability to discover kind of new reserves, our ability to take them on stream as quickly as possible, and then, of course, everything with our operations. So this is how to reduce the cost. What we're seeing is that we need to drive a productivity revolution in our industry, but I think it actually goes cross-industry. We have a lot of inefficiencies in the way that we work. So even a lot of things that we maybe have moved from paper to digital, it's still just kind of digital paper, in that sense. So we have a huge kind of step to come forward, and I think the expectations of society is growing more and more to us as well, to kind of to be better with what we have, to use the fuel more efficiently, to use the people in a better way, and to really kind of just drive efficiencies throughout the value chain. And that's something we're relentlessly pursuing, that try to get rid of waste.
On society, right? If we talked about the convergence of what's coming together with the digital transformation age, and as well now the global crisis and sustainability, right? We now have a discussion in our society about how we use, even our heating, how we use the gas at home and whatever. And now we have the discussion about how we could be more efficient, because rather changing the source, that's one thing, and that's most difficult to do, right? But maybe you can be more efficient with what you have already, right? And again, it's about the data and the insights, right, in that.
But I also think, let's face it, shareholder value, I mean, shareholders will be interested in what are we doing as OEMs or companies or, conglomerates, how are we managing, our carbon footprint? And I think all of us have shareholders, right? And this is one thing that I believe they will be looking at in the future. I know when I do trading now, I think about, and I think with oil and gas, it's even more interesting that you guys have the pledge, because You know, as you say, sometimes there's this, you know, feeling that the industry has. So it's exciting that you guys have this.
I think so too.
I think it's the consumer itself, right? It starts with the consumer, where the people become more sensitive about you know, how the value chain is producing emissions and whatever, you know. So just the end consumer itself will be asking for it, which then goes through all of the industries.
And I think most of us up here have a 2030 target, right? So we should come back and celebrate 2030.
And I think the main difference between, I mean, we have always tried to improve our process technologies to be more efficient. I think that was always our goal, even in the last decades. But the real difference now is that the situation will change completely. We have a complete exchange of energy sources. I think that's really what makes the difference. And here we see a lot of new process technologies which have to be developed. And there was a complete paradigm change now.
With your long experience at Thyssen, Sascha, have some concrete examples of successes or outcomes of the organizations you have worked for?
Yes, of course. So I think the difference regarding digitalization, in the first years, maybe more than 10 years ago, we started with digitalization, and we first tried to create more transparency. So we developed tools to give guidance to the customers, to have more visibility, and we also helped them to analyze the process data, and so that was the first step, I guess. And now we see, and that was already very, very good, and it also allowed us to have a much better customer support, because we were able to look into the plant data also from remote locations. Customer could get in contact with our experts very easily, very fast. We did not need to travel to site, and so therefore we have saved a lot of time, money, and also we did a lot to the environment, I guess. So that was very good. Then now the next phase, which is now ongoing since a couple of years, is we brought in some what we also call digital twin, so a process model of the real plant, which runs in parallel to the actual plant and allows the constant comparison of real plant data with simulated data. And this has really, again, made some additional improvement, like profitability especially, and overall plant performance, which leads also sometimes to a reduction of energy consumption, but also in terms of product quality. We have done also a lot of projects in increasing the product quality for our customers.
Interesting. I mean, this transparency aspect, I think this is definitely also very interesting beyond efficiency, of course, and beyond the decarbonization aspect. It contributes to be more transparent with regard to your own plants. Very interesting. Greg, from your perspective, what would be the consequences or the long-term consequences if we ignore digital?
So I was thinking about that, and I'll use an American company as an example. There was a large company in the US called Sears, right? And Sears had a catalog. Every child, every Christmas, couldn't wait to get the catalog, because you could look at the toys and you could see it and you could circle it and you hope that your parents would get it. And Sears, because of that catalog, they had one of the most successful mail order businesses for more than 100 years. But at the same time, Amazon as a retailer was growing. And originally, Sears had the view, you know what, we have the catalog, we're fine. And they didn't think about digitization of their services. They didn't really plan on that. They didn't think it would impact them. Now, it didn't happen overnight, of course, because Sears was a more than 100-year-old company. But within 10 years, Sears is now defunct. It's bankrupt. It's gone out. So what happens if you don't, I mean, you can't avoid digitization, right? And I think, as one of my university friends once said, you can avoid it, But within 10 years, a company like MAN, for example, within 10 years, if we completely ignored digitization, we would be a skeleton of a company, right? And so I think companies, just like Paula mentioned with you, with your iPhone, I mean, imagine you not having a smartphone. I mean, my mother is 83, she has a smartphone, right? So digitization is part of our everyday life, and it's part of our everyday business. So I think if we don't do it, we don't have a future.
You know, it's like at boarding school, if you don't eat your lunch fast enough, someone will eat it for you, right? And, you know, it's like what we say at Amazon, you can't fight gravity, actually, right? And that's what you were just talking about with your mother having a smartphone, right? If the consumer is asking for something or has a need and is going in that direction, or a society or is going into a certain direction, it has a reason, right? And if you don't have the will to reinvent yourself and to question your business model, you were just citing Sears, but there are others like Kodak, right? Or let's look at WhatsApp and SMS, right? I mean, the SMS numbers were going through the roof, and then WhatsApp came and, you know, it all crashed. If you don't have as a company, if you don't have the will to reinvent and rethink your business model, even if it might cannibalize your core business, then it could be that you run out of business in the future.
Absolutely.
You're spot on. And that's what MAN did, right, so like 150 years ago with the diesel engine. But I think it's two things, right, that people need to grasp. So one of which is this kind of like this acceleration of technological development. So, and this is just a wonderful thing of human innovation. We develop faster, we adopt faster, we deploy faster. So this is just the kind of the race track that we are on. And this, of course, it impacts us as consumers, we feel that, but it impacts us as companies, even large companies, you know, like Kodak, they have like 150-year legacy, completely kind of transformed. But then the second thing is how this human innovation and this kind of technology and digital factor is transforming the business. And if you take like the FT 500 as an example, you can look and see that companies are joining and leaving that list faster and faster and faster. So like the age of companies on that list, shorter and shorter and shorter. So we need to kind of really live with this sense of nothing is permanent. And if you don't fight for your place kind of in the market, somebody else will, as you said, eat your lunch. And I think there's something that we see in industrial companies that is not really grasped at all kind of levels and in all conversations. And we need to really get behind this, because this is things will never be as slow and as permanent as they are today. And you can't really say that it's slow and permanent.
That's the work that Craig is doing here at MAN, right? Transforming the business. In the end, it's about reaching a certain agility of the business, as you also touched upon it, to reach an agility to even in a downturn, right? Exactly. To stay in business and to adjust your business to the way where you need to go, right? Exactly. If you have so many inefficiencies in the company and you just stay stable and I would say the opposite of agile, I'm losing the English word here right at the moment, but like the opposite of agile, stiff or whatever, then you don't have a chance.
Yeah, but there might still be, of course, smaller companies and companies who are still thinking, is that really the right approach? What is the starting point? Where should such companies start? What's the first thing you have to do?
Well, first thing you need a vision, and you need that to be linked to your business outcome. So when I look at, like, from an Aker BP perspective, you know, we're very clear on our low cost, low carbon vision, and then we have, you know, metrics for this. We know what we want to hit. And then kind of from the digital perspective, like, our vision is to be the first data-driven oil and gas company in the world to support that vision. So you need a vision, you need to connect that to the business value, and then you need to have a kind of a portfolio of initiatives that deliver on short-term value and longer-term value. So that, I think, is like how you described as well, that you need to be chipping away, and you need to be changing actually the everyday digital lives while you're going after the big transformative things, because if you don't do that, then the gap between reality and the vision gets too big. And people can't really...
You mentioned a small company. A very good example is most larger companies already digitized. So if you're a small company, a supplier, your customer is already demanding that either through request for proposal or through the invoicing process, you're already forced to go digital. You don't have a choice. So I think for the smaller companies, this is really challenging because, as you know, even in the industry, a lot of RFPs now are completely digitized, right? And they even go to the point of where you should do a digital signature. Now imagine that in some companies where you have very thick hierarchies of who should sign, you're supposed to quickly turn around a digital RFP within a very short time with a digital signature. I mean, at the same time, we're being forced. The wave is pushing us toward digitization. The question is, do you have a plan, as you just mentioned, and do you do it with chaos, or do you do it with a plan? That's the bottom line.
Well, I think, the very important thing, what do you need to do? Well, either the owners of, family-owned companies or even the C-level or CEOs of companies, they need to actually be vocal about that transformation. If the board and the C-level is not vocal about this and not being in it, they won't take the people along, So you need to really over-communicate even, and you said it, you need to have projects where you generate quickly successes which have an outcome for the customer and the business, right? That they really create value, and then you can build on top of it. Because that's, as human beings, we need points where we can create trust and what we can believe in. And if we have these projects and we have this data that they are successful, then you kind of follow on.
But Chris, we also need to brag about it, and we all have this discussion, right? I mean,
like over-communicating.
If you're in a traditional German industrial company, right, you don't really want to talk about things until they're perfect and ready to go to market. And we know in digitization, you're doing iterative development. You're coming out with version release 1. You're coming out with release 2. And if you wait to the final release, then of course no one knows.
But there is no final release, right?
Exactly. It's continuous development. And I think there in itself is really the big change, because if you're used to taking a piece of metal and turning it into something and then selling the metal, it's a huge transformation from digital services. Because how does a sales guy, if he doesn't understand the value proposition of a digital product, he can tell you all day long about a piece of metal. So I think this is also this transformation, not just the people on the platform doing the work, but it's also the sales staff, the marketing folks. It's A to Z. Everyone has to have an understanding in a very simplistic way. And I think that's key, because sometimes techies love to talk about Kubernetes and all kinds of big terms, and we just need to break it down very simply.
But then we are at a point where we normally ends up all the time, and it's a people's business. So how to deal with culture? I mean, you enlarged already on that a little bit at the beginning. How to deal to build up skills and talents, and how to deal with resistance. I mean, of course, not everybody will be happy with this digital transformation process. How to catch up with those people, Paula?
I think one of the biggest mistakes that we make, apart from what Greg said about just being way too technical and abstract that nobody really grabs it, is that we don't really take the time to explain the why. And I think a lot of people, I would say including us, if change is just forced upon us with no rationale, your human instinct is to push back. Because, to be quite frank, people don't like change. They like other people changing, actually. That's fine. Those guys could change, but no, I'm good, So, but I think taking the time to actually explain the why, and to get this kind of common shared sense of urgency, and to explain kind of the transience that we're in now, and how we feel that will increase, and how we believe that kind of, I think our industry, as well as yours and the other industry, we are going towards a survival of the fittest kind of state. So what do we need to do to be the fittest? And I think when we really take the time to articulate the why, not just expect people to blindly follow us, then I think that we actually get the buy-in that we need. But we shouldn't underestimate the biological human resistance to change, because it's in all of us.
Yeah, that's what we also found on the client side sometime. If the operators and also the managers operating plants, what I mentioned earlier regarding transparency, sometimes they are not really willing to accept that transparency. So sometimes it needs more convincing talks to really also convince the customer personnel that they will also benefit from the products, not only maybe their boss will ask them, why haven't you done this, and why is that still not working, or something like that. But in the end, maybe, it's always about the value that it has also for the individual, right, and what they are getting out of it. And the example you just touched on, if you give more transparency, more data, you gather more data on a production line, you give more insights, you can be more efficient. It could be even beneficial for the people. Sure. They could do more breaks, or they can even adjust their shifts better in a better way, be more efficient, and they could be home or have a better work-life balance, whatever. So that, on these simple things, you can just take people along, and where you can ensure the trust of the people, that they trust in this transformation.
What's the biggest risk for resistance? What do you think?
I guess we just articulated it, isn't it? It's how to bring people with you. That is the biggest risk.
I think it's how to get them to come with you without making them feel intimidated. I think that's the key. I mean, we're doing a lot of work with AWS on training for our employees, including our board. And part of it is giving them the safety of being in a small group to say, what is the cloud? Mm-hmm. Because we use these terms like, they're every day. And if you ask somebody, what's the cloud? It's in the sky. Mm-hmm. And I think the first thing is, going back to what Paula said, is rethinking how to bring the people on board first, because people are terrified of what they don't know. Yeah. And of course, just like anybody else, if someone's talking about the cloud, the cloud. And I even see this in my everyday life. People talk about the cloud like they know it like the back of their hand, when in fact, I know they don't really understand it. And so I think a lot of it is just giving people the safety and freedom to ask questions about technology so that you can bring them along. There will always be resistance, but you focus on the ones that want to come along, because you can't bring everyone. I don't know your view, Paula, on that.
Just sorry to touch on this, because to lower the risk, you need to allow that people fail in this process, and actually that you have failure. So you have to create a culture of failure is actually an option.
Now you're talking crazy.
Right? Yes, absolutely, I can do. But we did big failures as Amazon, right? The Fire Phone was a big failure, right? The Fire Phone. Yeah, exactly. What is it? But it was a big failure. But what we did is, in our company culture, nobody was fired because of this, nobody was punished because of this. But what we do is always about these things, right? You can fail, learn about it, analyze it, right? The next time you fail better, fail again, fail even better, and then you get it right. And if you have that culture that it's totally okay that you don't know what the cloud is, or you don't know what the new digital plan is about, or whatever, it's totally fine. Just, if you bring up that learning mindset to the people, and that's what I think that closes the loop actually pretty quite well. Humans like to learn. They like to evolve.
It's the learning mindset, and it's the psychological safety to be able to ask those questions and not be ridiculed first, so that it's okay to say you don't know. And then it's the culture of failure. And there's a great one with SpaceX. I think it was 12 times they tried to launch that rocket and they failed. Time after time after time after time. They were using up all of their money to do it. The 13th time they made it. And Elon Musk was my CEO. He actually got to spend some time with him. He said he asked him, what you let it go that far? And kind of thinking about our businesses, would you let it fail 12 times? When would we have pulled the plug? But basically he said, yeah, of course, there's no better team in the world that could have made that 13th time, except for that team that had failed all of those times before. Yeah, but it's like you can invest in failure, or failure can be an investment, I think is really... But one of the things that I think is really important when we're communicating digital, and I feel very strongly about this as well, is that the people that we have in the industry today, upskilling them on the digital side, I think that is much simpler than kind of devaluing all of that industrial experience and then just bringing in data people, So I think it's to really get that message across that the experience that's in the industry today is so valuable. And if you just add some kind of digital skills to your existing experience, that's like a superpower, so that people don't feel like we think we should replace everything that's there, because that's not the
final question with you with regard to the time. How can we make sure that digitalization remains a priority topic, especially in these times of crisis? We have COVID, we have other crises all over the world. And of course, some people might say, okay, digitalization, yeah, important, but we have other issues to deal with. How can we make sure that this remains a top priority?
Well, I think it was a top priority during COVID, wasn't it? I mean, really, like many of us had no option but to really embrace digital to actually continue our day-to-day business. And I just shared as well, I listened to one of the inventors of the AstraZeneca vaccine yesterday, and she talked about how their kind of platform approach to their vaccination research center enabled them to develop it in 8 months to parallelize the processes, and they also were able to receive snippets of DNA sequences from the Chinese researchers. I think that is all super fantastic. But I think, to be honest, there really is no choice, right? It's not this is not an either or. Can we do our traditional business and ignore digital? Because this is a wave that's kind of unstoppable for any of us here. I mean, we just look at how our whole lives have been transformed. Obviously, industry is a little bit slower, but I think in the industrial sense, we've overcome actually a lot of the challenges we've had with, like, you know, legacy systems, cloud migration, all of these things that were slowing us down in the past, done a lot of lessons, failures. We know a bit better what it takes to move our organizations, and the technology is there. So I think if people choose to down prioritize it, I say good luck to them.
But I think Chris also mentioned it. If it's not, it needs to be on the agenda of the board and the C-level. And as I mentioned, with decarbonization, digitization is a partner. And certainly most companies' strategy is decarbonization, so they have no choice, as Paula mentioned, because without digitization, they won't be able to measure their effectiveness, they won't be able to improve their products, they won't be able to tell the story. So I think there's no choice.
If we ignore it, we ignore the customer, to be honest. Customers, as I said, are wonderfully, beautifully unsatisfied all of the time. And so we miss the market.
And as I said in the beginning, customer demand is definitely there. They are asking us if we cannot offer digitalization, then someone else will offer it. And also, we all know that digitalization also helps us to improve our conventional products as well. So all the all the chemical processes we can offer, of course, also benefit from getting data, from plant data, which we can also use to improve our conventional business.
Absolutely. Good. Thank you very much. Dear spectators and virtual visitors, we could certainly continue with this interesting discussion for quite some time, but the time is up and we have to come to an end. I would like to thank our panelists very much and for their contributions and for sharing their know-how and expertise with us. And of course, I would like to thank you, dear spectators, for joining and tuning in. Have fun when exploring the other virtual rooms of the Digital Industry Summit of MAN Energy Solution 1. Once again, thank you and goodbye.
Hi, my name is Benedikt Ackerschott and I'm a sales manager for Power-to-X. At MAN Energy Solutions, we are working on solutions for the big challenges of our time. And despite my colleagues and myself are part of the static equipment, we are moving big things to zero by looking into all viable ways of power to gas and power to liquids. Or in short, we are building the home of synthetic fuels. And that is what I'm going to present you today. At the beginning, I'd like to discuss the utilization of CO2. Then I will give you an overview about different routes for CO2 utilization with a focus on power to gas and power to liquids. After that, I will show you which solutions MAN Energy Solutions for CO2 hydrogenation can provide or is working on. If we want to decarbonize, why should we use CO2 instead of storing it completely? The main characteristics of renewable energy sources are that they are volatile and therefore not available 24/7, and that the regions with the highest wind or solar potential do not match the highly industrialized areas with the highest demand. Therefore, we need a possibility to store and transport renewable energy. Besides hydrogen and ammonia, hydrocarbons such as kerosene, gasoline, or synthetic natural gas are an option. In fact, hydrocarbons are a derivative of green hydrogen to make it easier to handle. This leads to one of the biggest benefits of hydrocarbons, which is the existing infrastructure like storage facilities, import or export terminals, seaports, pipelines and gas grids, and so on, up to petrol stations. Another big benefit is the possibility to, let's call it, optimize the fuel for the application. For example, we can use methanol, which can also be produced in remote regions of the world with reasonable technical effort as a bunker fuel for ocean-going vessels. And for aviation, we can process methanol into kerosene to gain the requested higher energy density. And what I like about green hydrocarbons is that we can also use them as carbon neutral fuel for the existing fleet of airplanes, ships, trucks, cars, etc., which often have a long lifespan. Before we look at the technology, how to provide CO2 neutral hydrocarbons, let's have a look at the demand side, for example, in Germany. As you can see on the left-hand side, almost all studies forecast an increase in demand by a factor 6 or 7 by 2050, and most of the energy based on power-to-liquid fuels will have to be imported. Germany is therefore a good example of the mismatch between the availability of renewable energy and the demand. Having said that hydrocarbons are a viable way to transport and store renewable energy, we now take a look into the different routes of utilization. Okay, so let me start by looking at the feed. Hydrogen and CO2 are the starting points for the three different routes we want to highlight today: methanation, methanol synthesis and downstream derivatives of methanol, and finally Fischer-Tropsch, including reverse water gas shift. Methanation. The methane produced, also known as synthetic natural gas, can be used in all applications that currently use fossil natural gas. For example, for process heat in industry, for domestic heating, or as a base chemical or for mobility. Methanol is a clear liquid organic chemical and the simplest member of the alcohols. Due to the wide range of applications from paints, carpeting, plastics, and other everyday products, it is one of the most widely produced chemicals as a building block for the chemical industry. It is also a clean burning fuel used in a wide range of applications, from cook stoves and boilers to bunker fuel for ocean-going vessels. Another application of methanol is the one-step conversion into drop-in gasoline, or the conversion of methanol to kerosene, which is currently in development and has not yet been certified as a drop-in jet fuel. The process is more complex than methanol to gasoline and begins with methanol to olefins, secondly oligomerization, and finally hydrofinishing. By the way, a certain share of gasoline and diesel is produced as valuable byproducts of this process. Finally, I'd like to introduce the Fischer-Tropsch process as a possibility for CO2 conversion. The Fischer-Tropsch process is a mature technology that converts syngas, which is a mixture of carbon monoxide and hydrogen, into liquid hydrocarbons. The challenge is the upstream conversion of carbon dioxide to carbon monoxide, which is called reverse water gas shift reaction. This reaction is endothermic, meaning that a large amount of heat is required for the process. The objective of the current development of the reverse water gas shift process is to increase its efficiency and to use renewable energy instead of the combustion of fossil fuels. Having taken a more theoretical approach, why the utilization of CO2 is necessary and which routes of utilizations are viable, let us have a look now at solutions for CO2 hydrogenation at MAN Energy Solutions. Why is MAN Energy Solutions so heavily involved in decarbonization? Let me give you an example. As the major player in two-stroke engines for the ocean-going vessels, our engines are responsible for around 1.5% of the global CO2 emissions. This is only one reason why we are actively working throughout the whole company on solutions to reduce CO2 emissions released by the shipping industry and also to contribute to the decarbonization of other sectors such as aviation, chemical industry, and so on. So why is MAN Energy Solutions not only focusing on hydrogen? As you can see, for transport and storage of renewable energy in general, and technical applications like mobility in particular, the energy density is the key. Or in other words, the lower the amount of energy contained in the fuel, the larger the tank has to be. If we then look at a liquefied hydrogen as a cryogenic fuel, which has to be transported at minus 253 degrees Celsius, additional volume for boil-off to keep the temperature needs to be taken into account, which makes things more complex. That is the reason why hydrogen is not a silver bullet, but the building block to enable CO2 utilization. MAN Energy Solutions unlocks the full potential of renewable energy by providing technology for power to gas and power to liquids. In other words, we provide solutions for transporting and using renewable energy in a place far away from where it was generated by solar or wind. Starting with methanation at MAN Energy Solutions. MAN Energy Solutions has developed its own methanation process. Based on our MAN DWE reactor technology and process know-how from our lab, we are a one-stop shop for methanation from pre-FEED studies to plant commissioning. What I want to highlight is that we are using just a single MAN DWE tubular reactor for the methanation process, which is equipped with a steam-based heat recovery system. Furthermore, our methanation process does not require a recycle loop to achieve excellent product quality, which reduces the complexity and the footprint of the plant, and thus the cost. There is also no silver bullet regarding feedstocks. As the market for methanation is emerging, feedstocks may vary. For example, pure CO2 and hydrogen, or a biogas plant, or a gasifier. MAN Energy Solutions has taken this into account when developing the methanation process. Our solution can be adapted to different feedstocks and ensures the same high product quality. We have built our first reference in 2013 already, the methanation plant for the Audi wind gas project in Werlte. You can see the methanation reactor system provided by MAN Energy Solutions in the picture with the number 3. Based on the operational experience and continuous development of the process technology, there are a lot of improvements for the current second generation. A water-cooled reactor system due to reduced operational temperatures, reduced footprint, and therefore reduced investment cost. And most important, we have improved the product quality from 92% up to 98% methane content. MAN Energy Solutions is not only able to provide key components like electrolyzers from H-TEC or the DWE methanation reactor system, but to provide the full scope of EPC. We are currently performing the system engineering for a 50 megawatt reference case, which will provide a good base for scaling up and reduced response times for projects. Moving on with methanol and its derivatives at MAN Energy Solutions. MAN DWE reactors have been successfully supplied for grey methanol projects by major licensors all over the world for decades. Nowadays, we have expanded our portfolio to include CO2-based e-methanol. From skid-based solutions for smaller applications to world-scale projects, MAN Energy Solutions is working with technology partners to provide solutions for this emerging market and the rapidly growing demand for green methanol. One of the most well-known projects worldwide, Haru-Oni, is currently taking place in Chile. For phase 0 of this project, we have successfully delivered a skid-mounted reactor system for the conversion of hydrogen and CO2 to methanol. This is a good example of the performance of MAN Energy Solutions in the field of Power-to-X, beginning with extensive support for the technology provider during basic engineering, carrying out the complete detail engineering, procurement and manufacturing of the skid-mounted system, followed by shipping, and ending with support during erection and commissioning. In order to achieve a fuel with a higher energy density, processing methanol into gasoline is an option that MAN Energy Solutions has been working on for more than 10 years by supporting our technology partner Chemieanlagenbau Chemnitz, CAC. The demonstration plant at the University of Freiberg in Saxony, Germany, has proven the quality of the process and the product. To mention all the advantages of synthetic gasoline from this process is beyond the scope of this webinar, but in short, the synthetic gasoline is of the best quality and has been used successfully in motorsport events. Our message today is that we are ready to supply methanol to gasoline plants in an industrial size. By the way, the MAN DWE reactor for the demonstration plant on the right-hand side is the first reactor I've ever sold. The mutual development of the methanol to gasoline reactor based on a MAN DWE reactor system has built a strong relationship with CAC. Therefore, we are also working together in the field of methanol to jet fuel. The conversion of methanol to jet fuel consists out of 3 steps: methanol to olefins, which could also be used to provide the chemical industry with olefins. Secondly, oligomerization, and finally, hydrofinishing. The complexity is therefore higher than in the methanol to gasoline process, but we will reach our objectives for the market entry and especially for the ASTM certification of the whole process within our planned schedule. Finally, Fischer-Tropsch. This is how the future of sustainable aviation fuel may look like. You can see on the picture 6 out of 12 gas-to-liquid reactors we have provided for the Pearl project of Shell in Qatar. These reactors are already producing synthetic fuels, which of course are still based on natural gas. The objective will be to run reactors like this on Power-to-X-based syngas, which is, a short reminder, a mixture of carbon monoxide and hydrogen. In the past, we have run more than 50,000 hours of Fischer-Tropsch process in our lab to develop with licensors the best design for Fischer-Tropsch reactors. Today, we are focusing on a more efficient way to run the endothermic reverse water gas shift process to provide CO2 neutral syngas. And I'm quite sure that in some time, together with our technology partner, we will again astonish the market. Thank you very much for participating. If you have any questions, please contact me. It will be my pleasure.
Good morning, good afternoon, good evening. Regardless of the time zone you're dialed in from, I welcome you to my talk at the first Digital Industry Summit by MAN Energy Solutions. My name is Hans Steinort. I'm a research engineer in our team for intelligent automation solutions, and it's an honor for me to be able to present this highly exciting topic of virtual sensors to you. Some of you might be here because the title of this talk contains one of the buzzwords that changed things fundamentally and disrupted not only our industry in the last couple of years. If we take a look at the agenda, we'll see that this buzzword, namely artificial intelligence, has its own chapter. That is because artificial intelligence, or AI for short, is on the one hand one of the main pillars our intelligent automation solutions are based on. On the other hand, there is often disagreement about the use and precise definition of certain terms. Therefore, so that we are all on the same page, I will go into which part of the wide field of AI we are in and give a brief outline of the basic functionality. If any questions arise during my presentation or remain unanswered, you're welcome to use the provided chat function. Our expert team will be happy to help you. So let's jump in. In recent years, our industry got an upgrade, version 4.0. You might have heard about it. With this current version, digital solutions are spreading to more and more areas and applications year by year, creating links that were previously unthinkable. The results are a higher degree of automation, better availability, self-optimizing processes, and smart monitoring. All of this made possible by collecting and utilizing data more efficiently and all the rapid developments in hard and software. Industry 4.0 is also often referred to as the fourth industrial revolution, a time of upheaval, but also of a spirit of optimism. That is why we are proud to say that we have our finger on the pulse of current developments and create added value for our customers with our intelligent digital solutions. In conjunction with Industry 4.0, IBM speaks of 6 core technologies that drive this current developments: Internet of Things, cloud computing, edge computing, artificial intelligence, digital twins, and cybersecurity. Our solutions, in particular our virtual sensors, run with 3 out of these 6 core technologies. But what exactly are virtual sensors? As the name suggests, virtual sensors are not physically existing sensors within the plant. Perhaps you are more familiar with the term soft sensor. This alternative term brings us closer to the core of the virtual sensor, because virtual sensors are software, more precisely digital models. Depending on which measured variables these digital models output, they can have 2 characteristics. They can either be viewed as digital twins, for example, if they simulate a measurement signal that is also recorded by a real sensor. In this case, we speak of virtual redundancy. Or they can be a purely digital component. That is, if the virtual sensor does not or cannot have a physical counterpart. In this case, depending on the area of application, we speak of virtual replacement, if a physical sensor is no longer required, or of virtual enhancement, if something is measured that could not be measured otherwise. Regardless of this definition and the area of application, virtual sensors always work according to the same principle. A target variable, the measuring signal we are looking for, is calculated or simulated from representative measured variables. This dependency on other measurement signals is also referred to as the dependency dissimulation. There are several approaches to how the virtual sensor ultimately arrives at its result. That means how it calculates the target variable from the inputs. These range from physical equations to multivariate methods to dynamic simulation models or methods of artificial intelligence. In our case, as already indicated, we use the latter, an artificial intelligence in our virtual sensors. In order to understand how virtual sensors work on the inside, we first have to distinguish between a few terms. Because when talking about artificial intelligence, some things are often mixed up. This can be confusing, especially when you're just getting started and exploring possible use cases. Therefore, I want to give you a brief introduction to the fundamentals of artificial intelligence. When talking about AI, these three terms come up most often: artificial intelligence, machine learning, and deep learning. As mentioned earlier, these terms are often mixed up, interchanged, or used synonymously. However, this is only partially true, because these three terms are not juxtaposed in what they describe, but rather are nested within one another. Artificial intelligence is the umbrella term that summarizes everything that deals with intelligent or learning behavior of systems. Machine learning is a technique of AI, next to other techniques such as search algorithms or logical systems. Because machine learning is probably the most popular method of AI, might be the reason why it's so often used synonymously. From a bird's eye view, all algorithms that fall under the concept of machine learning work according to the same principle. We use a large amount of data to learn a relationship between input variables and output variables. This works with home assistants such as Alexa, which translates spoken commands into actions, as well as with Tesla's full self-drive system, which translates image data into control commands, and our virtual sensors, which calculate a measurement signal from other measurement signals. They all use the same method, even the same way of learning, the so-called supervised learning. And what about deep learning? While it is one of the most common terms, we have not yet classified it. The simple reason for this is that deep learning is neither a method nor an algorithm of its own. If we wanted to embed it in this nested structure, it would be part of machine learning, because deep learning is closely linked to the aforementioned supervised learning, more precisely with one of the most commonly used algorithms for supervised learning, artificial neural networks. Amazon Alexa, Tesla FSD, MAN virtual sensors, they all work with these neural networks at their core. Depending on the application, these networks of course differ in the structure and the type of their input data. But the basic functionality is the same regardless of this. Data is fed into an input layer, passes through one or several hundred so-called hidden layers, and is combined into one or more output values in an output layer. Looking at this basic structure, we find the origin of the term deep learning. The first neural networks only had one hidden layer, often even just one neuron, the so-called perceptron. By adding more neurons and hidden layers, the networks became deeper. And in order to distinguish them from the original rudimentary neural networks, in recent years all networks with more than 3 hidden layers have been referred to as deep networks, which are used for deep learning. After clarifying this terminology, we now come to the basic functioning of neural networks and how they calculate an output from the input data. This happens with these connections between the individual neurons. Behind these are numerical values that are referred to as weights. In turn, these are simply put factors by which the value coming from the previous neuron is multiplied and combined in the next neuron with the values from the other connections and an activation function. These weights are initialized randomly within a certain range, which of course means that the output that is calculated in the first run usually does not even come close to the target value. And this is where the learning aspect of the AI comes into play. in this case a method called backpropagation. For this we use data that contains a known target value. That means it's clear which output variable is to expect from the various input variables. And this knowledge is used to train the underlying algorithm, to teach it these relationships, so to speak, so that later, when it's confronted with new unknown input variables, it can apply these relationships and calculate the correct output. To achieve this, the network calculates an output, compares it with the target value, and sends the observed error backwards through the neural network. By using partial differential equations and other algorithms to stabilize the learning process, the weights are gradually adjusted over many iterations with the goal to minimize the error between the calculated output and the target value. So, in summary, all the magic that surrounds artificial intelligence is at its core nothing more than math and code. Now that we know what virtual sensors are and how their core, the AI, works, we want to address the question of how we establish the connection between the real system with its physical sensors and our virtual sensors. As we said at the beginning, virtual sensors are software. But in contrast to other functions and algorithms, they are not implemented directly on the control system on a PLC. Although that would be possible in some cases, we decided to run them on an edge device, namely an industrial PC that is connected to the control system via a Profinet interface. There are two main reasons for this. On the one hand, this architecture allows us to quickly and easily retrofit and expand our automation solutions with intelligent modules, regardless of the manufacturer of the control hardware. And on the other hand, with virtual sensors, which act as digital twins for virtual redundancy, we have the requirement that they always reflect the current measured value of their physical counterpart. Therefore, we want to train them in live operation and learn in real time with real data. Fact is that neural networks, which form the core of the virtual sensors, can be quite performance hungry during their training. That means they take up a lot of process power, especially when several virtual sensors train at the same time. This would exceed the capacity of most PLC systems. Yet, we wanted to offer a solution that is not dependent on any services that run outside of the plant. By using an IPC and parallel computing functions, we get both. Scalability of the virtual sensors used according to customer requirements, and an island solution that runs independently within the plant. Virtual sensors that are not used for virtual redundancy but for virtual replacement or enhancement, such as AI monitoring of efficiency, are prepared and trained by our engineering department. For this, we use, among other things, dynamic simulations, digital twins of the entire system. You can find out more about this from my colleague Ms. Atyabi in her presentation, Dynamic Process Simulation and Virtual Commissioning. The virtual sensors pre-trained this way then also run on the IPC as ready-to-use modules and provide the operator with additional information about the condition of the system. Now to an essential aspect, because buzzwords, cutting-edge technology, and innovation are all well and good, but these things only really matter if they also are of practical use and solve challenges that were previously difficult or impossible to solve. In the course of this presentation, 3 potential use cases for virtual sensors were mentioned: virtual redundancy, virtual replacement, and virtual enhancement. These 3 use cases all aim to achieve significant savings through what at first glance appears to be a small software extension. First, the virtual redundancy. As mentioned at the beginning, in this case, virtual sensors run as digital twins in parallel to physical sensors and learn to imitate them. If physical sensors fail without proper redundancy, the previous go-to solution was to choose a conservative static substitute value. However, this can lead to a major problem, because depending on the current operation point of the system, this substitute value can violate defined limits, lead to a trip of the system, and cause significant downtime. In this analysis by ExxonMobil, we find that downtime of a system accounts for almost half of the total lifetime operating costs. As we all know, every hour of downtime is expensive and annoying, especially if the downtime could have been avoided. And this is exactly where virtual redundancy comes into play. Instead of having to rely on a conservative static substitute value, a virtual sensor that is operated redundantly to the failed physical sensor can provide a dynamic substitute value. And since the virtual sensor has learned the behavior of the physical sensor, the simulated measurement corresponds with a very high accuracy to that which would be output by the physical sensor, which in turn prevents a spurious trip of the system. Virtual replacement comes into play when physical sensors are to be saved on. In order to fulfill all requirements of functional safety, this case is currently only used in non-safety relevant areas. In other areas, however, a virtual sensor can replace a physical sensor, either completely or in combination with other physical sensors. For comparison, an evaluation by the process safety consulting company Connexus has shown that by enhancing a measurement from 1 out of 1 to 1 out of 2, the probability of failure on demand, or PFD for short, decreases by a factor of 15. With a 2 out of 2 to a 2 out of 3 enhancement, even by a factor of 20. This increase in availability can also be achieved with virtual redundancy by a virtual sensor, without the instrumentation scope having to be extended. In the last case, the virtual enhancement, a virtual sensor is used as additional instrumentation, that is used to calculate measurements that would normally not be measurable, such as the mixing temperature inside of a compressor or the efficiency of a component. The latter is used for AI-supported monitoring and outputs information about the unavoidable fouling of a component. From this, actions can be derived accordingly, and in turn availability and efficiency increases in the long run. The solutions presented are already being offered by our colleagues around Jörg Masopust for new construction projects. However, we are already working on retrofit solutions in order to be able to offer you intelligent upgrades and extensions for existing components. And here we come full circle with the selected hardware architecture. That means offering our intelligent digital solutions with an IPC as an edge device. As a result, you are not limited to the initially ordered scope of intelligent solutions, but rather can retrofit additional modules and newly developed solutions. Which brings me to the last point of my presentation, future developments. The potential of intelligent digital solutions is far from exhausted with virtual sensors only. As my colleague Mr. Masopust already showed in detail in his presentation, many more intelligent modules are planned or are already being developed. If you missed his talk on autonomous operation for turbomachinery trains, I highly recommend it. Because by exploring the possibilities offered to us by digitization, the availability of large amounts of data, and artificial intelligence, many more potentials can be unlocked. In addition to the virtual sensors, our portfolio will gradually be expanded with further intelligent digital solutions over the next years on the way to fully autonomous operation. These include an autonomous startup controller that uses AI and digital process simulations, or a controller for X-optimal operation based on an AI-enhanced model predictive controller. So stay tuned to find out more about our intelligent digital solutions for your applications. This concludes my presentation. Thank you very much for joining me. If you have further questions, you're welcome to use the chat function or contact me directly via email or LinkedIn. For now, you're welcome to enjoy the upcoming talks and discussions at the first Digital Industry Summit.
Dear valued customers, also from my side, a very warm welcome to our first Digital Industry Summit. I hope you enjoy the summit and will get as many as possible information about the products and offerings of MAN Energy Solutions. Let's use this time and talk about PrimeServe Industries Omnicare. In case of questions, please raise them in the chat window. What is Omnicare? Omnicare is a product name for our third-party business service offering, telling you that MAN Energy Solution is not only servicing machines and equipment, which it has originally built, and it stands for Omni, that means all, and Care, that we are servicing any kind of rotating equipment and its auxiliaries. So, what's new about it? This business is not at all new to MAN Energy Solution. So we by ourselves represent already a variety of own brands, like GHH, like Borsig, like Sulzer. In addition to that, we have a proven track record of third-party capabilities in many projects around the globe, with a variety of references servicing our customers. The new thing about Omnicare is the approach and setup we are taking to go for the services on these machines, combining our global competences and workshop network to find the right service solutions for our existing and future customers on your entire turbo machinery fleet. For each region, we have therefore set up a regional Omnicare center, which allows to be closer to you as a customer and collaborate with you on a daily basis. These spots are also staffed with experts in different disciplines to allow a different approach. With this approach, you even benefit more from one single supplier close to you and offering all relevant services to secure the availability and the efficiency of your entire fleet. So what does it take? Omnicare requires a different setup and a different customer relationship. To take over the ownership of your entire fleet, we need to work closer and together with you. This means we have to develop together the business model which suits best to you, your investors and insurance company requirements. Regardless whether it is a shaft line, meaning MAN equipment plus others, or fully other OEM equipment, we as an OEM can offer you the full service. We can integrate also other partners into a concept in order to offer you even bigger outages according to your requirements. For you, sure, we will be also in a position to offer you smaller packages. You see, there is a certain flexibility which allows you that we can tailor-make a solution according to your requirements. I fully understand that it's nice to hear this entire story, but what does it mean in detail? Let's have a look into our product circle. This means we can offer everything for a selective fleet of steam turbines up till 100 megawatts. We can service and offer our services for sure also on axial, process gas screws, gear type, radial, horizontal and barrel type compressors, as well as expanders. In the range of field service, inspection and repairs, revamps and modernizations on equipment, but also on I&C. And for sure also the entire exchange of a turbo machinery equipment on your plant site on an existing foundation. Besides that, and moreover, we can offer you large turnarounds and digital services, and if wished, covered by long-term service agreements over multiple years. If you are interested in these solutions, please visit also the speeches about these solutions during our fair. In all fields, and this is important, we deliver quality of an OEM, which also helps in your internal discussions with your insurance or owner requirements. Benefit from the solution of an OEM, of turbo machinery equipment and experience over more than 250 years. Now let's become even more concrete. And today I would like to share with you some insights into a small portion of our offering, which is our reverse engineering capabilities. And for this, I brought my colleague Romain Bayere with me, who will give you a further insight into this subject.
Thank you, Florian, and a warm welcome from my side. Reverse engineering has become a key competence for many of our service activities, and I will explain in a minute why is it so relevant to our Omnicare business. So the reverse engineering process is named as such because it consists in working backwards from an existing manufactured component through the original design process. It is based on 3D optical digitizing of the surface of an existing part using different types of technologies. MAN acquired the first scanner already more than 10 years ago, and basically today it's used in most of our product centers. In the video, I would like to show you some techniques displayed on some of our turbo machinery components. So why do we use such scanners and such techniques? First, they allow us to compare the model of the scanned component to the original CAD model when we have it. And it's therefore very easy to identify deviations to this original design. The first application of this is quality control, so that we can compare the deviations, for instance, for cast turbine blades freshly manufactured to their original design. The second application is inspection support. For instance, if you examine the split line of a casing during an overhaul, this technique allows us to define very easily or very quickly the needs for laser welding. The scanning technology improved a lot in the past decades and also the data processing. So today it's possible to scan the geometry of such parts at a very high accuracy. Second, it's possible to scan the geometry of parts everywhere in the world, basically, because these scanners can be portable devices. And third, the efforts for obtaining a CAD model are much reduced. So what does that mean for machines and components not originally manufactured by MAN? Well, we are able to obtain construction drawings out of such models without bringing these parts to one of our workshops. And this is, as you might know, a clear advantage for many of our customers who do not want to send out such parts. We can now use the windows given by them for scheduled, but also for unscheduled outages, because it's in many cases possible to dispatch such equipment on short notice. And we benefit here from the new Omnicare setup because, as mentioned by Florian before, we have now reverse engineering experts in each region, and we can dispatch equipment and qualified personnel often based in this very same country. So of course, there is some preparation time needed, for instance, to calibrate a scanner or to install the so-called targets that you have seen on the video. But within hours, we are able to scan a complete rotor or steam turbine casing. Our service center in South Africa has specialized in reverse engineering of blades for gas turbines, steam turbines, and compressors. Our product center in Berlin is specialized in reverse engineering of gear parts. So these are examples that show you we have now a reverse engineering network worldwide with an expert team which is based in Oberhausen in Germany that supports all these related activities. We can therefore today offer spare parts to our customers for third-party machines, but we can also offer other services, and one of them is footprint replacement projects, where through these reverse engineering techniques or the 3D scanning in this case, we can check the available space for replacing a third-party machine by a MAN machine. This technology helps us a lot. Of course, we are not the only company using this technology, this is clear. And also some of our customers use it. But there is a last topic that I would like to mention here before I hand over to Florian again. The models created for third-party components out of a 3D scan. They can be integrated and they can be modified into our design tools so that we can take into account new requirements from the customer, like efficiency increase, like capacity increase. And thanks to reverse engineering technology, we can revamp third-party equipment and we can integrate our engineering know-how to fulfill those customer requirements. And therefore, at the end, offer a competitive alternative to the OEM solution. And this is especially the case for so-called rebundling projects, where we reuse the original outer casing of a barrel-type compressor, and we insert our own MAN cartridge into this cartridge. That means for the customer, basically no modification, almost no modification to its machine train. That means a short outage, and that means still MAN proven technology. So this was my insight in our reverse engineering capabilities. Now back to you, Florian.
Thanks, Romain. Very good insight which you gave us into the capabilities. And this is not only limited to our product centers in Europe. We really have this set up around the globe with all our operations. Let's use this and summarize and raise the question why you should use Omnicare. You have just seen one small example of our capabilities, but the question perhaps still remains, why should you choose Omnicare? The reason for that is that you will benefit from one single service provider close to your operations, with the decades of experience and references in multi-brand services. So we will take over the ownership of your equipment. We can give you the full offering from field service to replacement of equipment. We can do the full train services, meaning all machines and all your equipment. We have a global network with quick and reliable responses, and we even exchange our knowledge between these spots, combined with the over 250 years of engineering know-how which we have in-house and around the globe. With that, we can extend the service life of your equipment, increase capacity, safety, reliability, and availability. We can help you to support the reduction of emissions. With the improved efficiency and reduction of emissions, you can run your sites more cost-effective. And you will be assured that you get the same standards and quality as you will get it from an OEM. Thank you very much for listening, and I hope you enjoyed it. In case of any questions, beside the fact that you could have entered or can still enter them into the chat box, please get in direct contact with my colleagues, which are also in the background of this fair. And your local Omnicare managers. In order to find them, please also have a look at our brand new webpage for Omnicare, which you will see here, blended in, and also on our booth. I hope you will enjoy the further stay. Thank you very much and stay safe.
Ladies and gentlemen, welcome to the first Digital Industry Summit of MAN Energy Solutions and H-TEC Systems. My name is Robin von Plettenberg, and I'm the CEO of H-TEC Systems. And today, I want to give you a brief presentation on H-TEC and how we are driving the scale-up of green hydrogen. Besides being the CEO of H-TEC, I also have 4 children, so you can say I'm a busy man. And when I think about the climate change, I also think about my children. Because by the time when I will retire, and maybe my children will have families, by that time, we have to have the climate crisis solved. And green hydrogen is going to play a crucial role in that. When I look at different applications that we need to bring down to 0 carbon emissions, there's one part which you can electrify with renewable energy. Residential heating, urban vehicles, and so on and so forth. But there are certain applications where this is not possible. And there it is necessary to have green hydrogen as a solution in order to decarbonize these applications and in order to bring the world to a net zero world. So if you look at chemicals and refineries, if you look at steel, international shipping, long-haul aviation, seasonal storage, these are applications where hydrogen is necessary in order to decarbonize them. And there is a number of applications where there is a lot of discussions whether it should be rather electrified or whether hydrogen will play a role. I think there is a role of hydrogen. I think it will be a matter of a business case in each application and also in each geography. So in some areas, there will be electrically driven trucks. In others, it will be hydrogen trucks, and so on. I see our task as H-TEC to be as attractive as possible for green hydrogen, because if there's a good alternative, this will also help to decarbonize the world. Our vision at H-TEC is to avoid 1% of all the global CO2 emissions. That's a huge task. It's a very tall order. And given that we are only a small company today, it's something that is really difficult for us to wrap our head around. But it is possible. And it electrifies and motivates our people, and it helps us to drive towards this specific goal. And the reason why we can formulate and put ourselves such a huge target is that we are in a very strong position with regards to our setup. Firstly, we are around for 25 years in PEM electrolysis. So we have a very good and strong technological understanding of PEM electrolysis. We are a 100% daughter of MAN Energy Solutions, but we have a very independent setup. So we are not part of the corporate processes and structures. And this helps us to be very quick and nimble in our decision making. So we can move very fast. For example, we brought our number of employees from 100 at the beginning of the year to 280 today. And we have sufficient financing. Our mothers have committed 500 million euros, which is a very large number for such a small company as H-TEC. So you can say as H-TEC Systems, we have a very strong core. But not only that. Since we are being part of the MAN group, we can also build on the strengths of MAN. I'm a former MAN employee. Also one of my board colleagues is. And throughout our organization, we have some people from MAN. And we get very strong support whenever there is something that we as a small company cannot do as well. MAN, of course, has a very strong industrial experience over not only decades, but centuries. And there's a huge competence when it comes to executing large projects. There's an EPC plant competence. There are industrial compressors and reactors, so other parts of the value chain. And there is a global sales and after-sales network of more than 120 hubs around the world. And these resources and competences are really easy for us to access and which can help us to serve industrial customers. And there's a third element, and that is MAN again is a 100% daughter of Volkswagen. And when we're talking about the scale up of the electrolyzer industry, we are talking about industrializing supply chains. And there's no industry that is as good as building up these industrial supply chains, serious production of complex products than the automotive industry. Volkswagen is the biggest automotive OEM, and there's a huge competence that we are building on when we're building new factories, when we are building up our supplier network, developing, validating suppliers, and so on and so forth. And last but not least, with being part of such a big group, we also have the financial security, the bankability. So our customers can rely on us being around for a long time. What we are doing as H-TEC Systems is we take renewable energy, be it solar, be it wind, be it hydropower, and we use that to split water into hydrogen and oxygen. And this hydrogen, as I've shown before, can be used in a multitude of different applications. And we at H-TEC, we are also serving all these applications. So there is a market for smaller electrolyzers in a containerized outdoor way. And there is a market for larger ones, which will be plants in buildings. And we will address both. We have a 25 years of experience, and H-TEC System was founded 1997, and it was primarily focused on research and education in the beginning. In 2010 and 11, GP Joule, a very innovative and pioneering renewables project developer, took over H-TEC Systems and brought the company more and more to bigger plants. So there was an electrolyzer launched in 2017. Our core product today, it was launched in 2019, which was already bigger. Then in 2021, MAN Energy Solutions took over completely. And now in this year, we have reorientated ourselves towards a much more ambitious goal, as I described earlier. Our North Star is to abate 1% of global CO2 emissions. And this is the path that we are now pursuing. Coming to our product portfolio, we are building on a stack. The stack is the core component of the electrolyzer. And our stack, the S450, we have developed in the year 2017. And since then, we have gathered loads of experience, 5 years, more than 70,000 hours in the field. And we have optimized the stack, and it's highly reliable and very efficient and has a very good performance. And we're using this stack in different electrolyzer plants. Today we have the 1 megawatt ME450, which is a turnkey solution, 1 megawatt optimized for plant sizes of 1 to 2 megawatts, sometimes 3 and 4 megawatts. The next bigger solution is our hydrogen cube system, or short HCS, containerized. These are 2 megawatt cubes containerized, which can be combined to 4, 6, 8, 10, also 12 or 14 megawatts. And next year, we will launch our first indoor solution for very large plants that will be in a building. And they are built on 10 megawatt modules, which can be combined to 100 megawatts. So you can see we are growing the plant sizes that we are offering, and 2023 will not be the end of the story. There will be bigger plants and bigger solutions coming as well. Having said that, we are not focusing only on the big plants. We will continue to serve the segment, the containerized segment of 1 megawatt, 2 megawatt, and so on. So what makes our electrolyzer special? Our target is to produce green hydrogen at the lowest possible cost, the so-called levelized cost of hydrogen, which are considering all the different factors of the process chain. And when you look at the LCOH today, they are primarily driven by the electricity cost. So about 70 to 80% are out of the LCOH are electricity cost. So efficiency is very important. And we are very happy to say that we have the best efficiency of PEM electrolyzers in the world, 74% for the whole plant at 30 bar level. This is a very important factor. Secondly, it's reliability. I showed you that the stack that we are building on has a lot of running hours, and we have a lot of experience with it. And we have a concept of inherent redundancy with rather small stacks that can easily be exchanged if there is a problem. So reliability is the second. The third one is the fast ramp up and load changes as you have it with PEM electrolysis. This is important because if you're working with renewables, they are fluctuating, and the better the electrolyzers can ramp up and down, the better it is because you're not losing electricity. And as I said, electricity is the main driver of the cost. We are also building on unique supply chain capabilities. We are building a gigafactory in next year, and we're building on the support of our Volkswagen colleagues, as I explained earlier. PEM electrolysis does not use any toxic chemicals, so there is no risk of environmental hazard. In fact, our electrolyzers are even standing in a Swiss natural reserve. And finally, we are a trustful partner. We have the bankability, and we have the proven project execution capabilities of MAN. Also, our service is quite unique. We are basically offering 3 packages. Starting at the bottom, there is constant remote monitoring from our control center in Augsburg, so that we are able to recognize problems in the electrolyzer, not only when they occur, but even before they occur. We are analyzing a lot of data, and we are developing this product more and more so that we really get more and more into this predictive monitoring mode so that we can inform the customer before something happens and then take preventive actions. Then secondly, we have a package of revision and repair where we are doing regular health checks on site and repair components so that the plant availability is very high. And then finally, we can even go to operations and maintenance, basically a full service package and run the electrolyzers in an optimal way so that you get the lowest levelized cost of hydrogen. Coming to our production sites. Today, H-TEC has 2 sites. There's on the one side the Hamburg location, where we have our competence center for the stack. So there's all the R&D for the stack, and there's the stack production. And we are planning to open a gigafactory by the end of next year. In Augsburg, there is the competence center for the electrolyzer as a whole. So all the balance of plant is being developed and produced in Augsburg, and we have our technical service center in Augsburg. Now coming to our capacities, we have an ambitious plan to extend our capacities with our gigafactory that we can step by step increase. It will be online in 2023. We will use 2024 to ramp it up. In 2025, we can already deliver more than a gigawatt, and we can extend that to 6 gigawatts by the end of the decade. And that is only one shift. So there's even more potential to ramp up and serve a large supply base with our own production. We are also not only building on Volkswagen competence, but we are in a research project, H-TEC, for industrializing the PEM electrolyzer production. And we are building on a supplier network, which is global. So we are increasing the plant sizes, we are increasing our capacities, we are building our personnel, and we are also increasing our regional footprint. And today we are focused on Europe, but we will step by step also address other world regions and then service the whole world. And we can build on MAN's PrimeServe service network with more than 120 hubs. So literally all the big electrolyzer projects in the world, we will have a hub close by where we can service, where we can make repairs and serve our customers locally. Maybe some of our reference projects that we have done so far. There is one quite famous e-farming project in the northern part of Germany. Quite famous because it is really a pioneering project. It's about mobility, so refueling stations, and also a district heating where the heat of the electrolyzer is used for nearshore residential heating system. We have an application in Haurup where we are feeding directly into the gas grid, and the electrolyzer is steered in a way that whenever the electricity prices are low, it starts producing, and when they go up, it goes down again. We have one in Sweden with a small microbit grid solutions. We have one in Switzerland, which is hydropower, located in the natural reserve, as I mentioned earlier. We have one interesting project in Germany, a 2 megawatt project, which is an open skid. So basically our containerized solution without the walls of the container. And it's feeding for a local, the hydrogen into a local steelworks. And finally, we have also sold our first HCS system for a mobility application in Switzerland. Just 1 month after we launched it to the market, we already sold it. It shows that the customers are really keen on getting our products, and there is a huge interest. Now let me close with describing a little bit the ecosystem that we are in within MAN. So the MAN application portfolio along the hydrogen value chain is quite broad. Besides H-TEC systems and the electrolyzers, there's also competence expertise for cryogenic storage systems. So big cryogenic tanks that can be used for hydrogen. There is a very large market share of engines which will be fueled in the future by hydrogen-based e-fuels. We have reactor technology and competence in our Deggendorf plant. We have turbo and screw compressors which can be used to compress hydrogen. And finally, there is EPC competence that can be offered as well, and that can be used to combine all these different parts of the value chain. It's a whole ecosystem that allows us to offer full solutions to our customers. With this, I want to close and thank you very much for attending this call, for listening in, and I hope you have a very interesting and inspiring day at this first Digital Industries Summit.
Dear ladies and gentlemen, welcome to our panel discussion on hydrogen here at the Digital Industry Summit by MAN Energy Solutions and H-TEC Systems. My name is Jan Hopper. I'm Head of Marketing and Communications here at MAN, and I will be happy to guide us through today's discussions. I do have 5 fantastic guests with me here today. 3 of them are live with me on stage here at the MAN Museum in Augsburg. 2 more are joining us from their remote offices. And together we want to use the next 45 minutes or so to explore the much expected hydrogen ramp up from the various perspectives of the market players. And of course, we also want to talk a little bit about what MAN Energy Solutions and H-TEC Systems have to offer to their customers in this field. Let me quickly introduce my guests to you, and off we go. So with me here live on stage are Dr. Uwe Lauber, CEO of MAN Energy Solutions. Next to him is Robin von Plettenberg, CEO of H-TEC Systems, and we have Mr. Andrew Emil, Vice President Sales at H-TEC Systems. Gentlemen, welcome. And that's not all. 2 more colleagues are joining us from their remote offices. I'm very happy to introduce a pioneer of the renewable energy scene here in Germany. Mr. Heinrich Gärtner is with us today, founder and managing partner of GP Joule. And GP Joule is a very well-known integrated provider of renewable energies. And last but not least, welcome Dr. Axel Krieger. Axel Krieger is founding partner and managing director at Digital Plus Partners, a growth equity investor focused on B2B technologies. Gentlemen, once again, welcome. I'm very glad you could make it, and I suggest we get to work right away. And for starters, I want to get a bit of a feeling for how you assess the overall situation in the hydrogen market from your various standpoints. So I'd start with a question to all of you and suggest we just do a quick round around the panel. So what I want to know is, before the backdrop of a global hydrogen ramp up, in your opinion, are we doing enough, and are we acting quick enough? Or simply put, where are the bankable projects and when will we see them? Uwe, you're next to me. Maybe you start first.
Yeah, are we quick enough? No, definitely not. We are very slow. In order to meet the climate targets and the 1.5 degrees Celsius, which has been defined at the climate conference in Paris, I really think we need to speed it up. There are a lot of discussions around hydrogen, which is okay, which is fine. There's a lot of money available, funding is there, but I don't see that hydrogen and hydrogen production is picking up as fast as it should be. So we really have to walk the talk and build large hydrogen plants, and not only having a pilot project here and there. And hydrogen as such is a global topic. It's not only that we have to do something here in Europe or in Germany. It's a global topic, and in countries like the Sun Belt, Middle East, Australia, Chile, I see a lot of activities, but we are not as fast as we should be.
Thank you. We are not fast enough. That's to sum up Uwe's statement. Robin, what is your perspective?
I absolutely agree with that. Hydrogen and the renewable space, they are not only anymore a weapon against climate crisis. We are now fighting against an energy crisis, and that's very serious and it's very urgent. And this is becoming a question of fighting poverty, of creating wealth, and also a question of national security. So we see a lot of talk. We see, I just read a report from the Hydrogen Council. There are 250 billion euros of projects, proposals on the table, but only 10% have a final investment decision, an FID. So there you can see there are a lot of ideas, there's a lot of talk, but when it comes to implementing it, we are too slow.
Okay. Mark, maybe what's your perspective on this? We are too slow. Obviously, there's project funding available, but we don't. We just don't get them on, bring them on the road. Why would that be?
So I can delve more into a bit of detail here. My own assumption, so those numbers are just my own best guess, is that out of every 10 projects, maybe one materialize. And that's also builds on what Robin mentioned, is that there is a huge volume, but it's not happening at the moment. And the simple answer is that it's a mix of everything, and that's an easy answer. But what it means is that we have lack of maturity on a lot of fronts, whether that's the funding processes, permitting processes, also on the local codes and standards. It varies even within Europe or German-speaking countries. It varies on the different inspectors, even within a specific company that come to commission or approve a plant. There is no standard, and that's due to the lack of maturity. And this is all evolving, whether it's on the permitting side or project appraisal side, or even as simple as even when the project is finally materialized. So I think we have to, and this is something maybe the other colleagues in home office can comment on, what is their experience when it comes to all these hurdles that are slowing us down.
Yeah, just very briefly from my understanding, when you say 1 out of 10 projects gets a real go in terms of investment decision, do we have a benchmark, like in other areas of business? What would be a percentage there? So is that a lot, or is that not a lot? It's 10%, or is that pretty much average?
Well, I think it's not a lot right now. You see that these are the proposals that are on the table are not just some random idea. These are real project proposals, and I hope that a larger share will materialize. But what you see right now is that the final investment decisions are not taken because of insecurity. What you need is the clarity about your investment. And right now this is very difficult to get because the regulations are not clear, the financing takes too long, and the projects are being delayed.
I think there's also a significant change which has came to us. It's the energy crisis, and electricity prices are tremendously high. And what I see is also that we have not invested in renewable energy sources. So since 12 months, nearly nothing has happened in Germany. So as a basis for green hydrogen, we definitely need a lot of energy, and this is not given. Second point, I mean, we cannot only blame the politicians that they are too slow in getting the permits. Looking also to H-TEC, the ramp up takes also time. Electrolyzers, the capacity, the coming from let's say a manufacturer status up to a serial product, that takes at least 2 to 3 years time. In addition to that, to the electricity price.
I see. Yeah. I see. We talked about investment quite a bit, and Axel, this of course is deep into your wheelhouse. Can you share your thoughts on how the investment situation is in the hydrogen world?
Sure, happy to do so. And I start actually 23 years back. So I'm a big believer in hydrogen. When I worked as a consultant, I did my first project on hydrogen in 1999. And back then, management of my client was very much committed to a breakthrough in 2 years from then. And it obviously, as we all know, did not work out. So over the next decades, basically, the breakthrough continued to be 2 years out. And now, luckily, it's different. We have the technology, we have the true commitment from the industry. And we have to act now. And that's obviously also reflected in what we see in the investment space. We see that there is true commitment from buyers of the technology, of users of the technology. And so from an investment perspective, we are very confident that things have changed and now is the time of hydrogen.
Okay, thank you. And last but not least, Heinrich, what's your perspective?
Yeah, as long as we allow to be measured on the climate goals out of the Paris contract, we are for sure too slow. And this on several stages, not just in the field of hydrogen and all the technology around that, even in the field of speeding up, building the renewable sources that can produce that hydrogen. So for that, we are too slow and we have to speed up. What we see out in the market at the moment is that there are a lot of stakeholders that are really okay with speeding up. And especially I want to mention all the big consumers of energy in which form ever, may it be electricity or may it be hydrogen, they are up to speed. They want to have that technology implemented today. We see the money there, like Axel said at the moment, everybody is ready to start. I think it's still quite a bit a question of regulations, that we don't start early and don't start with enough power. Yeah, what we saw over the last years, this COVID-19 pandemic on the one hand, now the energy crisis, that distracts a lot of people at the moment, a lot of our politicians in the end, from this goal and from this path that we should be on. So we can speed up and we should do that now.
Regulations, that is a good keyword, and I'd like to stay with you for a moment, Heinrich, to hear your perspective. I mean, actually, GP Joule is one of the few, one has to say, companies that actually has hydrogen applications in the field, mostly together with H-TEC systems. So, from your practical experience, what are the biggest hurdles to actually flick the switch on a project and make it happen these days?
There are several smaller issues that always arise when a new technology is going to develop. So for sure, as already mentioned, supply chain and ramping up the production is an issue, and that needs a lot of power at the moment, and in the end, a lot of money for sure. But that will be solved. I'm really confident about that. The technology is there. A lot of companies are working on that at the moment, and a lot of people are giving all their personal power to this point, and I see there no problems that can't be solved. The biggest issues at the moment, from our point of view, are still the regulations and a quite clean path and a clean way of looking forward. What is going to happen? So what we saw, just to pick one of these topics out, what we saw this cut in the carbon tax, for example. So for the next year, we won't see a higher carbon tax like that was promised years ago. That is something that don't give trust to this branch, and don't give trust to all the people that try to invest at the moment into these new technologies. So that's just one point. As we already heard, the time for getting permitting for projects in this field is also too long, and there are several regulations, especially on the EU level at the moment, that haven't been fixed up to now, so we don't have a reliable situation, and that is the biggest issue from our view, that stops at the moment, or that slows down at the moment the development in this field.
Yeah, reliable framework conditions, that's something I think I've heard from all of you today. Summing up the situation so far, it seems that the money is there from the investment side, the enthusiasm and the market story is also there. There's a lot of loose ends on the regulatory side. Question is the industry even ready? And moving on to you, Robin, and the supplier side, like H-TEC, a company who produces PEM electrolysis, would H-TEC even be able to meet the enormous demand for green hydrogen production? I mean, we heard 1 out of 10 projects. What if it was 5 out of 10? Could you still cover these projects? Do we have the capacities?
Yeah, so I mean, this of course is our primary concern. How do we ramp up? How do we get capacities as quickly as possible? How do we get the products into the market? And we are there moving with very high speed, and we have everything that it takes. We have a product, a technology that we know very well. We have been in the space for 25 years. We have the funding. We have 500 million euros committed by our mother, MAN. We have the serious production know-how through Volkswagen, which again is the mother of MAN, and we get a lot of competence there. So building up the capacities, building up new factories, the supply chain is something where we can learn a lot from the automotive industry, and we're getting great support there. And then last but not least, we also have the know-how of executing large industrial projects through MAN, which is in the space for decades or centuries. And so we have all the puzzle pieces, and we are now really ramping up our production and our supply chain so that we will be able to meet the demand that is coming in now.
So all the puzzle pieces are there. We just need to do some puzzling then. Axel Krieger, I want to come back to you once more to benefit from your experience as an investor facing this enormous need for growth that we're seeing in this field. What could this young hydrogen industry possibly learn from other industries? What mistakes could be avoided? I know we all have the photovoltaic situation in Germany in mind to remind us of how things should not progress. What is your perspective? Is there a benchmark that comes to mind that could help the industry?
Yeah, sure. So first of all, when it comes to comparable industries or comparable showcase in the past, I mean, clearly, and Robin mentioned one of them, would be automotive with electric vehicles, it's offshore wind, but also you can discuss about organic food and how developments are going there. What can we learn there? I think the most important piece is that we need authentic commitment of industry players. This is way more important than regulation. So we need strong commitment to reduce emissions, to accept and drive disruption, to accept obsolescence of existing investments. And that must be done by corporate managers and investors and the broad public. Here again, more important than regulation, it's the industry, right? I mean, the industry has to take the initiative to shape here and to be committed to the change. And second is obviously that we need a strong ROI for customers, but this ROI must be most likely bridged with taxes in order to get there long term. The second thing, I guess, is a given, and politicians are working on it, but the first one, that is the important piece, and that's where we need the commitment.
Okay, thank you. Staying at the demand that we're seeing, Andrew, you as a sales expert, which area, which segment, where do you see the biggest demand for now, in 5 years, 10 years? Like, are there clusters that are there first movers that you can identify?
So I would say the lion's share for demand currently and also in the future for the next 5 to 10 years would be the energy industry. So for renewable energy and also traditional energy players, they need large amounts of green hydrogen to supply their existing customers. Another industry would be the chemicals to produce the green ammonia or green methanol. And finally, oil and gas, where the refineries use huge amount of hydrogen to remove the sulfur for diesel and other refinery products.
Okay, so these are all big projects. I'm wondering, is that where the market will be going? Will we see like only the large-scale centralized production and then transportation? I mean, we have GP Joule, who have a strong history in decentralized projects. So will we see a mix in the future market? Andrew,
yeah,
sorry.
So I can say that we need both. So the decentralized is required, and I can give some examples to elaborate. Decentralized, for example, you can have, or we're working on actual projects, for example, in a steel mill where they have enough space to put solar panels and produce their own hydrogen for their own usage. So we need decentralized solutions also for remote communities or communities on in a mountain area or an island, similar to what the PV industry did with energy islands in Maldives and other areas. And we need the large XXL centralized projects. Good examples is Ludwigshafen or Rotterdam, where there are large initiatives for tens of gigawatts, where basically you have a lot of players where you can connect to the different industries, especially imports. So such concept gives the economies of scale, but you also need to serve other smaller communities that want to be independent and be able to supply their energy and hydrogen or industrial needs independently.
So it will be essentially the mix of both. And Heinrich, quick follow-up with you. What are your thoughts on central versus decentral, and is those will those big central factories also be something that GP Joule would be interested in terms of project development? Is that also your playground, or will you stay decentral?
Yeah, we see there a demand for both of these versions of hydrogen production in the future. For sure, there will be centralized production facilities in the future. What we see in the beginning is a much more decentralized production, as we saw in renewable energy over the last years. At the moment, what we see out there that the most competitive part to use hydrogen today is already in the mobility sector. So there is where we have a parity with diesel or petrol, and for that reason, it's easy to build projects there. We don't have to forget that the whole energy market is under a complete regulation. So there's always a kind of subsidies or a kind of tax on energy, and for that reason, we depend at the moment on the regulation here. And to step in this market means today that we need big subsidies to do that, like building hydrogen or produce hydrogen for a steel mill today can only be done if that runs under a good subsidized project today. That's not a way to do it on the market level. In the mobility sector, that's a bit different. And I just came back yesterday from a week business travel in California, a market where hydrogen is well established already in especially the mobility sector. And we see it is doable there to build up the hydrogen business in the end. But what they do at the moment is centralized production. So they only have 3 central production facilities for hydrogen. They use that in a liquid hydrogen way. And that what I experienced there could be a hurdle in the future. So for sure, we rely for the next years more on a decentralized production.
Okay, so decentral, bit quicker, easier to finance, obviously, but to meet the demand in the long-term perspective, we will need those large-scale installations. Thank you for this. I want to now spend a little bit of time on H-TEC systems and learn a little bit more about this company. And we all know the first thing you have to check if you're interested in the daughter is the mother. So I'm I'm turning to you, Uwe. Like MAN Energy Solutions has based its future growth strategy more or less entirely on decarbonization. So it's really in the core of everything. Moving big things to zero is our proud company purpose. Can you elaborate a little bit on what role H-TEC does play in our playbook?
I mean, in general, H-TEC plays a significant role in our strategy, and we have basically defined 5 large pillars of our decarb strategy, and we claim to be, until 2030, a decarb champion. So with the electrolyzers from H-TEC, you can, obviously you produce hydrogen, which plays a significant role for decarbonization. It's not only that we stay with hydrogen itself within our Power-to-X roadmap. Hydrogen plays a significant role for other industries. I'm always saying hydrogen swims and flies, and one of our main customer, of course, is the marine industry, and that is quite obvious. In the transportation sector there's no alternative than to decarbonize also the fuel. I mean, the marine industry needs to replace more than 300 million tons of heavy fuel oil via a e-fuel, so to say, whatever it is, whether it's green ammonia, green methanol, or green synthetic methane. And everything embedded or in common there in this e-fuel chain is, of course, it's hydrogen. So it's quite obvious. And I think it is very important that we speed up and ramp up the hydrogen. As I said before, 300 million tons, which needs to be replaced. Let's take that figure there, only replacing 1% of the 300 million tons means the production of 6 to 7 million tons of only hydrogen. So where does it come from? We need to speed it up, and we said it right at the beginning. Hydrogen plays the core, plays the center of the decarbonization strategy.
These are impressive dimensions indeed, but to be fair, we also know the shipping industry is a slow giant. So, Robin, can you feel that? I mean, we hear the demand is gigantic. If we look at the numbers, can you feel the surge? Is there pull from the shipping world that you can see and feel in the market?
Yes, definitely. I mean, there's an enormous pull from the market, from the shipping industry, from the airline industry. As Andrew mentioned, from chemical, steel. So there's since hydrogen is such a versatile element, there's also a lot of demand from a lot of different areas, and shipping is for sure one of the very big topics.
Okay, now we've heard from the owner, we've heard from the CEO. Let's talk to the customer. Heinrich, you've been working with H-TEC system a long time. Actually, you're part of the founding team of this company. What are your experience with H-TEC system? Like, where do you see their position in the market? What makes them stand out?
As we are convinced that over the next years, a decentralized production of hydrogen will be the entry door to a hydrogen market over the next years. We are really convinced that H-TEC at the moment is pretty well prepared for that market. For sure, the sizes of the electrolysis systems will grow in the future. We started with a few hundred kW and are now in the megawatt range, and maybe it will go in the double-digit megawatt range in the next years. But that is exactly the right path from our point of view. Like the project that we see coming up, so the bigger number of projects that we see coming up are exactly in that range. I think PEM electrolysis itself is quite good, prepared to cope with fluctuating energies, like we see that from renewable sources, and that renewable sources will be the biggest player in the energy production market in the future. That is a given fact from our point of view. So for that reason, H-TEC is pretty well prepared at the moment for this upcoming market. For sure, we know there are more of those manufacturers out there, and a lot of companies are working on that at the moment. But I see H-TEC quite in a good position here.
Thank you. And let's double check that with what the financial markets say. Axel, from your perspective as an investor, how do you look at H-TEC systems?
So H-TEC is, for me, and I think in general, from a market perspective, still considered a startup out of Germany, right? So a small player out of Germany, which, to be fair, is a good thing, since this also drives the culture of H-TEC. And this means that being an attractive employer for entrepreneurial and mission-driven talent is important right now. We still need this entrepreneurial mindset and culture to drive and shape the hydrogen revolution. So that's a good thing. At the same time, hydrogen will become mainstream, obviously. And for this, you need the power of large tech companies like MAN Energy Solutions and the Volkswagen Group. And question is if that is already that clear to the market, to be fair, right? That who really owns H-TEC and who's behind, and how can you play this card of being part of such a large tech group? And I think going forward, one day, I guess comparable to Porsche AG, we might see an IPO of H-TEC one day in the multi-billion range. And I definitely think that H-TEC has that potential for sure.
That is great. That is great to hear. And I'd like to stay with you for the moment. Axel and gentlemen, so far we've been mostly focuses on what needs to happen now to get things going. And I would like to devote the final sort of block of questions for today on the question, what will happen then? Like once we've climbed the hill, what's up on the hill? And Axel, I'd like to hear from you. How do you see the future of a European hydrogen industry? I gave that metaphor. We're climbing up a hill. What's coming then? Is this an industry on the rise to stay, or will electrolyzers be commoditized by Asian companies within the next 10 years, and we will see a sharp decline as we saw that sharp incline? What are your thoughts?
Well, so for sure. So let's not mess it up. As I mentioned before, I'm convinced that hydrogen will become a mainstream technology. It is key to a carbon neutral or carbon positive future by enabling renewables. So key challenges are technology alternatives like batteries, obviously, so stay paranoid on this. But also cynical decisions from politics, from countries like China or the US, with politicians like Tromm. I mean, those are obviously risks we have to consider. But what is even more important, Germany and companies like the Volkswagen Group have to have backbone here. You have to take the perspective that you can shape the success of hydrogen overall, and let us, as the German economy, not lose the leadership like we lost it, right, in wind, solar, electric vehicles, or autonomous driving. We were leaders in those topics, which were the right topics, but then love and commitment to old technologies, lawyers, and lack of entrepreneurial spirit actually made us fall behind. Let's not fall into the same trap here again.
Couldn't agree more. And Heinrich, I'd like to hear from you on this topic too, because you were there when we lost solar and large chunks of the European wind industry. What is your lessons learned when we look at the upcoming hydrogen industry now?
As GP Joule, we see the energy system as one system. And everything is related. All sectors of the energy world are related to each other. And for this reason, we see hydrogen as the backbone of the energy future of the energy system of the future. So that is, from our point, already safe. Now we have to develop the right industry behind that. For sure, the supply chain should be safe. We should take care that we can provide all the products that we need to bring in the market over the next 10 years. That is really a big demand. We heard already high numbers that have to be met there. But hydrogen will be in the middle of all that. And for that reason, it's the right field to invest. We know today we have something like 20% of all our energy transmitted via a copper grid. 80% still rely on molecules, and that will change in the future a bit more electricity. But as we see again, to expand that grid, to build new transmission lines, it takes really a long time too. When on the same moment we have quite reliable grid in the gas sector that we should use. And I think, again, if you come back to our very first question, how do we do enough? We don't do enough because we are too slow at the moment. And for that reason, we should use all that infrastructure, especially this one that already exists. And that is a new way and a good way for hydrogen.
Thank you. So a bit of a takeaway message for me. Hydrogen seems too big to fail. Would you agree with that, Uwe?
Yeah, well, if I would not agree, I would not push that technology, and I would not support the huge investment. And Robin said it already, we invest nearly 500 million euros in that business. So at the end of the day, we need to make money. I'm a little bit struggling on the technology itself and your question, will it stay within Europe or Germany? And I think with our strategy that the stack is the core element of an electrolyzer. Yeah? And this stack we need to protect as much as we can. So having said that, we made a decision also to invest in Germany in a stack production facility. And with the support of Volkswagen, I'm pretty sure that we can build up let's say, a plant which is nearly 100% automated. And that means also from a cost perspective, I'm quite sure that we are cost competitive, although producing the stack in a high-cost country. But you never know. So I have also a little bit a strange stomach feeling thinking about the let's say, photovoltaic business. Why has it happened like it happened? So we need to do something totally different, which means we need to protect the stack, the know-how, the core element, and keep it in Germany. And with a highly automated process supported by Volkswagen, I'm 100% sure that we can do it in Germany as well.
Robin, some quick thoughts from your side.
I mean, if you look at the photovoltaic industry, a lot of the innovations came from Germany in the early stages. And then once it got a little bit more into mainstream, I wouldn't say commodity, but in more into that direction, China moved in with a huge investment. There is one big difference, though, and the solar industry was building on the semiconductor industry, which had already moved to Asia. And I think there's a difference with the electrolyzer industry, but nevertheless, right now we're in a stage of where still the technology is being developed and optimized. It's there, but it still needs to be optimized. And there's a great network of know-how in Germany with different research institutes, with very good people that we get on the German market, and that is helpful. But it won't last forever, and we have to keep innovating, and we have to industrialize our production, as Uwe said, and keep our competitive advantage by running down the cost curve.
Thank you. And yeah, time is flying, gentlemen, but I have two more points on my list with regards to the future aspects that I quickly want to raise with you. And Andrew, one of them is customer segments of the future for H-TEC. What is your perspective? Do you see specific regions that will be clustered or specifically of interest to you? Do you have prioritized regions or segments based on how they, the order they will enter the market? How do you approach that?
So when it comes to segments, we covered that briefly earlier in the discussion that chemicals, oil and gas and energy will be the largest segments for the next 10 years. And this is where we're going to focus. When it comes to regions, Europe is a pioneer for the moment, and that's where most of the projects and developments are, and that's what we will focus for the next couple of years. We see also new markets picking up, and this is of course the large industrial countries like China or the US, but we need to of course focus on what we have in hand and also our home region, which is Europe.
And Robin, one last question for you. And I mean, we have not one thing we have not spoken about yet is the supply chain. And obviously, we could do a panel discussion just on that topic, so it's a bit unfair to just give it to you in one question. But yeah, the past years have been overshadowed by bottlenecks. How are you positioned there, and where do you see this critical issue developing? Will it resolve, or will we see more troubles ahead?
So I think in general the whole climate change, or the fighting the climate change, is heavily relying on raw materials and the supply chain. So we have to move from a fossil industry into a mineral industry. Also, if you look at electrification and copper and so on and so forth. Having said that, also with the growth that we are ahead of us, this topic will be a core competence for us in the future. And the good thing is there are two things that are playing in favor for us. The first one is it's very clear to our suppliers that hydrogen industry is on the rise. So we get a lot of attention from our suppliers, the first-tier suppliers, the second-tier suppliers, also very big suppliers where we are comparably very small. The second one is Volkswagen again, because Volkswagen is such a huge player. They, of course, have access to all the different suppliers, and going there together with Volkswagen, having the big brother or the big mother beside you is very helpful. So we do get a lot of priority. It's very good to see, but it will remain a topic for the next 10 years, I assume.
Yeah. Obviously, H-TEC system, neither H-TEC system nor Volkswagen can fix the global supply chain, but it's very comforting to hear that H-TEC is well positioned thanks to a network of companies that we operate in. And on that note, dear gentlemen, ladies and gentlemen at home, that was it. We are at the end of our time. I'd like to thank you very much for joining me today. This was a great discussion. Hope you enjoyed it too. And to you, ladies and gentlemen out there, thank you very much for tuning in, and goodbye.